Okay, recording in progress. Good. Okay, vectors H2 max. We're gonna start from the beginning. Because I think it's better if you just start from the beginning in case you missed out anything. Okay, so I prepared some notes. I'll send this to you later. I'll be annotating it. Let's take a look at the syllabus first. So 3.1, 3.2, 3.3. Are you scared? Are you scared of vectors?
Yes.
Okay. Here I'll tell you. Don't worry, it's okay. Point 1, point 2, point 3. Only three bullet points. Compared to biology, this is nothing. Compared to biology, this is nothing. Biology is a scary one. So here, point 1 is the basic stuff, right? You just need to know all of these facts are at the back of your mind. There will be questions that test you on it, but they focus, they are phrased in terms of equation of a plane, equation of a line, and they are just making use of this, in particular ratio theorem, and magnitude, and all the others. What else? Okay, the main focus should be on the 3.2 and 3.3, which I will go into more details later. Dot product and cross product. There are two definitions to each of them. I'll go into more details later. And also, in recent years, they always like to test you on geometrical meaning. Okay, what is the geometrical meaning when you take dot product and cross product? Right, same vectors, they are same direction, different direction. You're just basically varying the value of theta. Then you will get all the different identities. Then 3.3, 3D vector geometry, you just need to know what's the equation of line, equation of plane. There are three versions to each of them. I'll go more into details later. Then one of the key tricks is to find the foot of a perpendicular. Later I'll give you some recipes, method 1, step 1, step 2, step 3, step 4. You just need to follow, then you can answer most questions already.
Okay.
Okay, right? And also finding angle. It's basically application of 3.2. Dot product in particular. Always dot product. Then the interaction between two lines, a line and a plane, or between two planes. This one you really need to be able to visualize. Later I'll draw for you. Here's a line, here's a plane. What's the relationship between them? And yeah, they also have relationship between two planes. Last time there used to be in the syllabus in relationship between three planes, which is even more difficult, but it has since been removed.
Oh, good.
Good. Okay, Ken. Now, yeah, you also need to know about what skew and coplanar, but I'll go into details later. Okay, let's begin. So, crash course H2 max. Vectors, first thing you need to know is just an arrow. It has a direction plus a magnitude. So something like this, okay? It has a length and a direction. Yeah, so let's say, for example, you have a point A, 1, 2, 3. Then there's this thing called the position vector of OA. So if you can imagine, you don't really need this, but just for fun, this is x-axis, y-axis, and z-axis. Okay, then where's 1, 2, 3? Maybe somewhere here. 1 unit in the x, 2 units in the y, and 3 units to the z. So it ends up somewhere here. This is A. Oops. A, 1, 2, 3. And then what is a position vector OA? It means you start from point O and you move towards the point A. Pink color, can see?
Oh, yeah.
Okay, that's vector OA in 3D space, but you don't really need to visualize this. A bit too difficult to draw, and there is no time to draw during exam. So what you need to know is this notation, column notation. By the way, I prefer square brackets. You see why I prefer square brackets? Because you see, if I draw round bracket like this, 1, 2, no more space, 3. Then I need to zigzag and then extend. Very ugly.
Oh.
Smarter if you use square bracket because you can do this like this, then halfway, 1, 2, no more space, extend beyond the bracket. Never mind, I continue 3, and now I can extend like this without a trace. You didn't even know there was a disconnect here. Square brackets are nicer, just an aesthetics thing. But if you use round bracket, it's fine as well. I prefer square bracket because I can do that trick. Okay, so that's the x, y, and the z component. Okay, I'm sure you know all this. I should go a little bit faster. Okay, also you need to take note of this notation. Letter, small letter with a tilde below. In textbooks or in exam questions, they will bold it like this to represent a vector. So I put down tilde here is not for fun. It's really to tell you this is a scalar. I'm sorry, this is a correction. This is a vector, not a scalar. Are we clear on that?
Yeah.
Okay. Then also you need to know the IJK notation. I with a tilde below. Oh, sorry, I should mention this. TILDE. TILDE is the curly line that you see. It's called a tilde. Yeah, so I tilde is just a vector 1, 0, 0. Also, if you visualize it, there's x, there's y, there's z. Where's 1, 0, 0? It's over here. 1, 0, 0. Oh, then you have a vector from the origin towards 1, 0, 0. And likewise, you also have another one. Let's say I use red color. This one will be 0, 1, 0. That would mean this red color vector is j tilde. The pink one is I tilde. Where do you think is the last one? K tilde 0, 0, 1.
Like on top.
On top, right? This last one now. Okay, good. So I'm running out of colors. This guy, I'll call it 0, 0, 1, and then this will be K. Okay, so you know all these basic stuff, but I think your problem with all this is application. So let's just talk more about it. Okay. Another thing to take note. Okay, over here, if you got point A, 1, 2, 3, you can represent it as position vector. And I already mentioned these two different this notation here in square bracket. But there is also this notation. Are you aware of this?
Yeah.
1i plus 2j plus 3. You just need to collect the blue color terms. Of course, they can also be negative. Just be careful. And you see this blue color box with 2 stars and a green highlight. That's main point of the day. Let me delete and review. Just read off the coordinates. Just read off the coordinates. In other words, 1, 2, 3 will correspond directly to these 3 components. And where do you get 1, 2, 3 from? It's actually the points, the coordinates of the point. Clear?
Yep.
Okay, good. Next point, position vectors. If you know this triangle, it's called triangle law. I'm not going to talk more about it, but basically, from point O go to A, from point A go to B, resulting vector A to B. Right? So in other words, OA plus AB equals OB. Agree?
Yeah.
Okay, but then you can make AB the subject, so OB minus OA. What do we call this? Position vector. The trick here you must memorize is N minus start. Are you aware of this?
No. Like I just do like opposite like that.
What do you mean? Are you drawing something?
No, like I try to remember how to do. So like I see AB, so I know like the B is at the start, then the A is at the second one.
Sorry. Please remember it like this. Left to right. So left guy is start, then right guy is end. So always N minus start. Okay. Then the letter beginning can be O, can be P, can be A, can be any other letters. Usually we pick O because it's easy. We usually pick O because it's easy to work with. Can you remember this for me? N minus start, position vector. You can break down any vector you like into N minus start. So vector A, vector B. Where's my N? It's B. So you write down OB. Minus away, the start, which is OA vector. Can? Okay, good. Arrow. I'll send you the file later, don't worry. Then after that, also very advantageous to put O here because it means that you can read off the coordinates directly. You can convert from a point directly into a vector. Don't need to think so much. But now, let's say, sorry, we now look at the next idea, which is length, magnitude, and modulus. So let's say you begin with a vector OA like this, 1, 2, 3. Okay, and let's say you begin with and you want to find its magnitude. How do we do it? Very simple. Review. Square root of each component. So 1 square, 2 square, plus 3 square. 1 square plus 2 square plus 3 square. Then you square root the whole thing. Is that okay?
Yeah.
Can, right? I think I saw you are working, you did this. So now if you simplify the insides, you get 14. So square root of 14. Now take note, I want you to please remember this. Don't try to simplify it. Sorry. Essentially, this is Pythagoras theorem. Okay. But sorry, I'm going ahead. I'm going too fast. Wait, I'll talk more about that later. So square root 14 is the answer. But essentially, this is just Pythagoras theorem. But extended, right? For extra plus c square. Can?
Yeah.
Okay, good. Then now let's look at this example. Vector OA, vector OB. 1, 2, 3, 4, 5, 6. How do you find vector AB? You just need to use the formula from before. N minus start, N minus start. Actually, this one is from O levels. N minus start, N minus start. Must remember. So let's take a look. What is N? It's OB. What is start? It's OA. So 4, 5, 6 minus 1, 2, 3. As a result, we get 3, 3, 3. Can?
Okay.
Then how do we find the length of this? What would it be? Oh, I review already. Square root of 3 square plus 3 square plus 3 square. I think you know this now. So square root 27. Then you can split it up as square root 9 times square root 3. Square root 9 simplify as 3. So 3 root 3. Is that okay?
Yeah.
Okay, take note. Here, Yeah, wrong. Sorry. I didn't write this down. Wait. Okay. Sorry. I realized I didn't write this down. Please leave answer in exact form. Cert. Okay. Cert means got square root, cube root. Can please leave it in exact form. Because the question will usually require you to use this information to prove something on. So it's a good habit to learn to leave your answer in exact form. Don't go and round off using into 3SF using the using a calculator. Don't do that. Just leave it in exact form. Okay.
Okay.
Okay. Next. Okay. Next one is unit vector. Okay. So what is a unit vector? It's basically you take the vector notation, you put on a hat on top. It's a vector. It's a very cold day outside, and then he put on a hat. But what happens when you put on a hat? You become in the world of vectors, maybe the hat very heavy, so you squish the vector, so it becomes shorter. Shorter means you have to divide. Divide by what? What do you think is this? What is this? What's square root 14?
The length.
The length, exactly. So now divide by magnitude. That's the main idea you must remember. How do you get a unit vector? You just start off with the original vector, vector A, and then you put on a hat. Put on a hat means you have to turn shorter because it's squishing it. So you divide by the length or magnitude. Three different names, length, magnitude, modulus, they mean the same thing.
Okay.
Can? What happens? What is the length now of this vector after you divide by length? You start with a length 3 vector, you divide by 3, what do you get?
1.
So what's the length of this vector? OA hat?
1.
Exactly. That's what unit means. Unit is English word for 1. It's an old-fashioned way of saying 1. Okay, unit vector means 1, length 1. Okay? Length is 1. Length is 1. Okay, moving on. This is very simple. I think I'm going a bit too slowly. Let's just go on. Parallel vectors. Let's take a look at vector A, which OA, which is 1, 2, 3, vector OP, which is 3, 6, 9. So what do you notice? They are parallel, right? They are parallel because you can draw a picture like this. Let's say this is 1, 2, 3. Then this one is 3, 6, 9. They are parallel. How do you prove that they are parallel? Let's say the question asks you to prove or show.
Like factorize out such that like it becomes the first vector, but like times by a factor.
Yeah. So in other words, you are saying this, right?
Yeah.
OA equal to K times of OP. Some number you factor out. Can be a real number, can be fraction, can be negative, can be irrational, can be anything. Just a number. So let's take a look at this simple example. What I started off with is OA. Then I realized that I can rewrite it as 1/3 times 3, which is just 1 times 1, 2, 3. But if I times the 3 inside, what do I get? This one I never discussed. Scalar multiplication, I hope you remember. You have to times each of them.
3,
So it
6.
becomes 3, 6, 9, coincidentally. And so there's a scalar here multiplied by 3, 6, 9, which is your vector OP. So what I've done is I rewrite vector OA as 1/3 times of vector OP. This part okay?
Yeah.
And let's review. Cotton, scalar multiplication, arrow, arrow, arrow. This one I hope you remember, quite obvious.
Yeah.
Times in only. Okay, so what we have done is shown vector OA is K times of vector OP, and therefore they are parallel. Maybe I should write down. This implies that vector OA is parallel to vector OP. Of course, you can walk the other way around. Then you say 3 times of OA is equal to vector OP. But in this case, the K will be 3. Just the other way around also works. Can? Okay. Okay, then geometrical interpretation. This one I draw a nice little picture. Let's say you got a line, you got point O, point A, and point P. Where's vector OA? It's here. Where's vector OP? It's there. Oh wait, sorry. Actually, technically, this one I have to mention that there's a difference between what we call position vector and free vectors. Here, what I've drawn are free vectors, meaning even though you see point O is here, point A is here, you will expect point OA to be on the black line itself, right? But here, this blue color one I'm drawing is what we call a free vector. Don't really need to know too much in detail, but free vector just basically means they are floating around. They can start from anywhere. Okay, as long as length of the vector and the direction, the angle that it makes is the same, they're parallel, then we can say that they are equal vectors. Oh, that's why I put my OA floating on top. Can? Mic test can hear? Okay. Mic test, can you hear me?
Okay.
Okay, good. I can hear you too. Okay, review. What is the main point? The geometrical interpretation when you have a scalar is that you will scale it, or in other words, the vector becomes longer or shorter, but it is still parallel. Okay?
Okay.
Of course, if it's negative, you can go in the opposite direction. Like for example, -4 times of vector OA. Right? You just extend it by 4 times, but negative, so you go in the opposite direction. Okay?
Okay.
Okay, good. Next. Collinear. What is collinear? Collinear is basically saying that you have 3 points. Must be 3 points, not 2 points. They are telling you that you want to let's say you have a question and they somehow have a very long-winded question and they ended up with 3 points. They want you to show that they are collinear. How? Here's the procedure. You start off with the position vector of each of them. Right? Just read off the coordinates. Read off the coordinates. Right? Then how do you show that they are collinear? You always make 2 vectors. Okay, take a look at this picture. Point A, point B, point C. They are collinear. Collinear, oh, sorry, I didn't mention. Means they all lie on the same straight line. Do you know that?
Yeah.
Okay, good. Then what you need to do is to make 2 vectors. So in this case, I have to first involve any 2 points. So for example, I pick vector AB. I pick A and B, then I find a vector AB. How do I do that? Same thing as before, n minus start. N minus start, must remember. So n is 225, start is 123, subtract away, I get 102. Agree? Okay,
Yeah.
next vector, we have to pick 2 other points. Can we pick vector BA? I pick AB, then I start BA. Cannot. You have to involve the third point. You see, you pick AB and you pick BA. You never involve the point C. Point C very sad. Point C very sad, very lonely. You must involve the third point. So that's why you must pick either AC or BC, or CA or CB. Can? Of course, you can also pick BC or CB, but yeah, whatever, it doesn't really matter. What's the main point is that the second pair, it must involve a third unchosen point plus another point. The another point can be anything. Okay? Third unchosen point, which is a point C, plus another point. Is that clear?
Yeah.
Okay, good. So now you pick vector AC. Then of course, again, n minus start, OC minus OA, blah, blah, blah. You get the working here. You can check yourself. So at the end of the day, trust me, you get 102 and -20, -4. You can verify yourself later. Now you have to, the next step is you need to prove that these 2 vectors are parallel. Okay, imagine in another scenario, if they are not on the same straight line, A, then B, then C. Where's my vector AB? It's over here. Where's my vector AC? It's over there. What do you notice? They are not parallel, right? So in contrast, if you got 3 lines which are collinear, vector AB and vector AC must be parallel. So that's what we're gonna do. Prove they are parallel. Then we can immediately conclude they are collinear. You can also check the working here. Basically, I factor out a -1/2 from the vector AB. And I realize it becomes AB equals to -1/2 times the vector AC. So K times another vector, where K is -1/2, therefore they are parallel. Is this conclusion okay?
Yeah.
Then therefore you conclude they are collinear. Okay? Yeah, you need to know this. Any other things I need to take note of? Yeah, nothing much. That's all. Collinear done. Any questions?
No.
Next one. Okay, good. Ratio theorem. Okay, now I give you some weird, funny story to help you remember. Make sure you remember. You quote this. You go and check your MF26 ratio theorem, and you know how to use it. So magic gray triangle. Ratio lambda is to mu. Lambda and mu. Sorry, I should write down. Lambda is to mu. They are Greek letters. They represent numbers. Can be any numbers. Lambda is to mu. And point in between a point C, a duck feet bone, crisscross, and then conclude. Do you know what I'm talking about?
No.
Okay, so basically, right, whenever you want to use ratio theorem, you better make sure you got this diagram over here. The duck feet bone is just a mnemonic to help you remember. Duck, remember, a cute little duck with a duck web feet like this. If you zoom in on one of its web feet, what do you see? You'll see this shape. I zoom in for you already. You see that it's the same triangle. Okay? Okay? And what's so important about duck feet is that this is duck feet, not enough. You have a bone in between, duck feet bone, Very important, duck feet bone. You never draw the bone, you cannot continue. No bone, then too floppy, cannot swim, huh? Must have bone. Must have basically the vector in between, the bone, okay? Can you understand?
Okay.
I think maybe not so clear. I just look at this actual diagram, which you have to draw. So in this diagram, you have a point O, a point A, and a point B. You always have a point C that's in between. Okay, then you have a ratio. They'll tell you vector, line AC, line CB ratio of lambda is to mu. Oh, by the way, if I tell you that C is the midpoint, what's the ratio? If C is midpoint?
1:1.
Correct. Yes, 1:1. Please take note of that. If C is midpoint, then 1:1 ratio. Okay, so with this formula, what you need to do is you first draw your magic gray triangle. Then you draw your pink color crisscross. So now you see your duck feet. It's incomplete. You still need your duck bone. Can you understand?
Okay.
Okay, I must have this diagram. Point A, point O, point A, a point that's in between with a ratio. Then crisscross, this one is highlighter, and then you draw a line in between. Crisscross actually don't need to draw. Crisscross you visualize in your head, but the duck bone must draw. So what you must draw is triangle, a duck bone, O, A, B, point C in between, and the ratio, lambda, mu. Maybe if you want, you can circle the ratio to make it clear to you it's a ratio. Okay, then you conclude vector OC must be equal to lambda times of OB plus mu times of OA divided by lambda plus mu. What is that? How do you interpret that? Take a look. Here is OB. What's opposite of OB?
The lambda.
Lambda. So that's why you got lambda times OB. Then you have to add on. Mu times OA. What's mu times OA? Vector OA is here. What's opposite?
The mu.
The mu. So that's why you have a mu. Then you just have to divide by the total. Okay? Understand how to use?
Okay.
Okay. I'm not going to go through examples for this one because it's a bit long-winded. I'll go through it when I reach the questions. So application will be in reflection about a plane question. You can have a point that is, you have let's say you have a line L, R equals A plus lambda B, and then you can have a reflection about the line. This one is called reflection about a line. Sorry, I should have mentioned this as well. About a plane / line. That's version 1. You want to find out what is the coordinates of this P prime, given that you know the coordinates of P, let's say 1, 2, 3. Okay, you need to find out P prime, the reflection about the line. You know what's a reflection, right?
Yeah, like the opposite. Yeah.
Basically, you can see hidden magic gray triangle here. Can you see? And dark bone in between. What we call the foot of the perpendicular. We usually denote by F or N. Foot. So then you can use ratio theorem here. You need to figure out some point A here, maybe point A. Then you got magic triangle. But point A is not so good because it's quite complicated. So we should introduce a new point O. Then we can draw our magic triangle over here. Can see or not? Can. Then you have to draw the magic triangle, draw the dark bone in between, use ratio theorem. Here, what's the ratio? If you know that it's the reflection.
1:1.
Very good. 1:1. Then from there you can work out what's the ratio. Maybe I'll just quickly write it down. What would this be? It would be vector OF equals to what? 1 times of, if you look diagonally across like this, 1 times of vector OP prime.
OP prime.
Plus or minus?
Plus.
Formula says plus. So we put plus. What's the other vector? What's the other ratio? Here, the opposite there.
The 1 times of OP.
Very good. 1 times of vector OP divide by 1 plus 1. Clear?
Yeah.
Ratio theorem. In this special case, we call it the midpoint theorem, but you don't care. Just use formula only. Some formula only. 1 plus 1. Okay? Good. Can move on. Oh, sorry. One more thing about plane. Of course, if you reflect about a line, you can also imagine you can reflect about a plane, right? Imagine a line like this. It cuts at this point and then it goes down and then it continues. Then you can have a reflection of this line. So you can have a mirror image. Right. I'm testing my art skills already. I hope you can visualize this. There's a plane basically going on here. And then you have a line that goes down and then a reflection of the line. This is line L. This is line L prime. Our goal is to find out what is L prime. is equal to, sorry, I shouldn't put equal sign here. It should be a colon. Vector R equals to A plus lambda B. Our goal is to find out the equation of the line L prime. You are expected to know how to do this as well. That's in the ASRJC paper. Okay. Yeah, but then they give a long-winded story about, wow, here's a lake, a missile hit here, missile hit there, whatever. Just trying to make your life difficult. How to convert the English story into an equation of a plane. You're supposed to know this diagram. Okay, I will go through it eventually. I don't think I have time today, but let's move on. That dot product, point 8 now. What is why do we call it dot product? It's because of the notation A dot B. A dot B, that's why it's called a dot product. Okay. It's also known as a scalar product. Why? Because when you multiply them together, what do you get at the end of the day? You will get a scalar. Scalar means what?
Like number.
Correct. Yes, just a number, not vector lah, basically. It's not a vector. Okay, no direction. Okay, next. Main thing you must memorize. Okay, wait, I should test you first. A dot B is equal to modulus A times modulus B times what? What's the quantity here? Really cannot remember. Oh no. Must memorize. This is the basics of the basics. Cosine theta, not sine theta. Must remember.
Oh.
Okay, cosine, dot product. Can? Okay, height. What was it again? A dot B is?
Cosine theta.
Is it just cosine theta? What?
Modulus A times modulus B times cosine theta.
Very good. Okay, how to remember this? Mascot Michael Jackson doing Smooth Criminal Lean. Have you seen it before?
Yeah.
Okay, so you see, there's an angle he makes against the ground. Can you see this pink color? There's an angle theta in between. Okay, I call this vector A, vector B. It's linked to the projection shadow. Can you see? If you imagine there's the sun on top, then they'll be casting a shadow below, right? So let's just simplify the diagram a bit. So if you imagine this is my Michael Jackson, okay, a pink color arrow, and then this is the floor, vector B. Oh, sorry, I should label this is vector A. Then you can imagine if the sun is directly on top, it will cast a shadow here, right? Can see or not? Pink color shadow. This shadow is associated with cosine theta, correct or not?
Yeah.
Because you see, what is cosine? So I hope you remember adjacent over hypotenuse. Adjacent over the hypotenuse. Adjacent is a shadow. It's related to the shadow. Not sine. Sine will be opposite over hypotenuse, right? So you'll be related to perpendicular distance. So that's how you memorize it. Length dot product is associated with, okay, dot product is associated with shadow. Shadow means it's associated with adjacent. Adjacent, then you remember car. Then you remember C. Then you remember is cosine theta. If not, if you find this a bit too difficult, then you better jolly well memorize the basic definition. This is supposed to be memorized. Okay?
Okay.
Okay, next formula number 2 to memorize. You have to know what is how do you do the calculation? Let's say you have the 3 numbers 1, 2, 3, and 4, 5, 6 as vector A and B. What is A dot B? You just have to
plus
pair them up and then multiply. Correct or not?
Correct.
1 times 4, 2 times 5, 3 times 6, then just put plus in between. Okay? You can verify on your own 32. Do you need an example? Or can I move on?
Can move on.
Move on. Okay, must memorize these two. Okay, can. The vector product one will be a bit more complicated. Then I'll go through it later. I'll give an example to practice. Okay, next, number 3, length of projection from formula number 1. So this is the formula. A dot B divided by the length of B. This is the formula. Do you want me to derive it for you?
Okay.
It's in the notes. But technically, you don't need it. You just need to memorize it, which is a bit memorizing.
Okay.
You want? Okay, should I explain? Okay, maybe I'll explain it later. But first, the things you must know. So let's call this a length of projection is basically a fancy way of saying shadow. Sun on top of a vector OA, and it casts a shadow, a gray color shadow. And I call the length of the shadow L. Okay, L. Then it will be this guy. What's this? Hey, what's this B hat?
The unit vector of B.
Very good. How do you get unit vector? You take the vector, divide by the length of the vector. So that's why you get the unit vector. This is in the syllabus, by the way. Let me go back to syllabus over here, where n is a unit vector. Okay, this is part of the this is geometrical meaning of this fella means shadow. Okay, shadow. This other guy, perpendicular distance. Later, then I talk about it. Huh? So just remember, dot product with the unit vector on the floor will be the shadow. What do I mean by dot product on the floor? Can you see this? This is the floor. This is dot product of Michael Jackson with the floor. Divide by length of floor. You get your shadow length. Does this make sense?
Yeah.
OA is Michael Jackson. OB is your floor. You take the dot product, then you divide by the length of the floor. Okay, I think it's better if I give some explanation. Wow, this one just giving you Michael Jackson doesn't really make sense. Let me give you the actual explanation. Okay, let me find the working first. Where did I put it? Scroll. I gave all the basic things you need to memorize over here. Then beyond that will be my more detailed explanation. So I explain again. Yeah, above is all just the formulas you must memorize. Okay, scroll. Let me find over here. Yes. Okay. So what you do, right, is you start off with a triangle like this. Opposite adjacent hypotenuse with respect to theta. Cosine theta is what? Adjacent over hypotenuse, right? So A over H. Yes?
Yeah.
Okay, good. Then what do we know about the formula A dot B? It's just mod A mod B cosine theta, right? Then
Yeah.
you can make cosine theta the subject. So A dot B divided by mod A mod B. Yes?
Yeah.
Divide over. So now, what do we know about cosine theta? Oh, it's A over H. So we can sub in. So A over H is A dot B over mod A mod B. Okay, cosine theta is A over H, so I substitute. Is this part okay? Okay, good. Next, let's move on. What do we want to find? We want to find the length of the shadow here, which if you compare with this triangle, is really just the adjacent, the A, right? So A and L are the same thing. So I can make A the subject, or rather the L. You can also call it L. So that means I just need to times the H over. Then I get A dot B divided by mod A mod B times H. This part okay? Times the H over, make A the subject. But wait a minute, what is H? H is this fellow here, which is vector OA. Then how H is really just a scalar, a length of this vector here. So that's why I substitute the H with length of vector A. Okay, OA is the same as vector A, OB is the same as vector B. Okay? Here. It's just the length of the vector. So that's why I substitute in my H with the length of the vector. But wait, a number, right? Modulus means that it's now a scalar, no longer a vector. So I can cancel off the numbers, right? Then what am I left with? A dot B over mod B, exactly what we wanted. The thing that I asked you to memorize. Okay, this is what we call a math proof. But for exam purposes, I think if you cannot process this, just memorize. Okay, but if you want, you can go look through the reason again. Yeah. So anyways, A dot B over mod B, you can also simplify the B over mod B, and therefore, review. It is just what I wrote down just now. L equals to A dot B, length of projection. Can? Okay, good. Let me think a little bit. Did I do anything wrongly? Oh, right. I should probably, just to be safe, in case this dot product, right, could end up being negative, right? This mod A, mod B are definitely positive. H is a hypotenuse, of course, it's positive. There's a chance that the A dot B is negative, right? Then you want a length which is negative, cannot be, right? So to qualify, I need to put modulus. Then modulus of a modulus, I can split it out into modulus top and bottom. Double modulus, you just need to do it one time. So, right, modulus just makes things positive. If it's positive, if you modulus one time, it's already positive. So you don't need to modulus again. So I remove this second modulus. So the formula should actually be modulus of A dot B cap. Can? Okay, sorry, I forgot about that. Let me just quickly edit that on the original notes. Then I'll resume there. Over here must have modulus. Over here must have modulus. Why? Prevent negative length. because length cannot be negative. Okay?
Okay.
Can length of projection done. Next one, angle between vectors. Okay, what is angle between vectors? Very simple. You remember this formula just now? A dot B.
Yeah.
Is mod A mod B cosine theta. Just bring the mod A mod B over to the other side. You make cosine theta the subject. Then very simple. Now you just need to know what's your vector A, what's your vector B. Sum into formula, solve for theta. That's all. Cosine bring over, become cosine inverse. Can?
Can.
Okay, let me show you. What was the main point? Oh yeah, it was here. Okay, so let's work with an example. Let's say you got vector A 1, 2, 3, vector B 4, 5, 6. How do you find the angle between them? Very simple. First, you need to just use the formula. So what does the formula request for? Vector A, we have already. Vector B, we have already. What else do we need?
Must have the modulus of both.
Correct. So that's exactly what we do. Find the modulus of the first guy, modulus A, you get square root 14. And then find the modulus of the second guy, square root 4 square plus 5 square plus 6 square, 4, 5, 6. Oh, then you get square root 77. A point I want to make over here is that you leave your answer in exact form. Don't key in the square root in the calculator, leave in exact form. Okay?
Okay.
Then continuing on, A dot B, sorry. Here I just use the formula straight away without using this cosine theta formula. It will give you the same result. The basic idea is to always make theta in A dot B the subject. You know how to make things a subject, right? I'm sure you know that. So that's why I do this. Okay, A dot B will be mod A mod B times cosine theta. So what is modulus A? Which is equal to A dot B. So over here, mod A mod B is really just square root 14 times square root 77, then multiply by cosine theta. Correct or not?
Correct.
But A dot B is also, you can write it like this, which means you can multiply out 1 times 4, 2 times 5, 3 times 6, add them together. Correct? Which gives you 32. So I simplify. Right hand side is now 32. And then you got square root 14, square root 77. Just bring over. Of course, actually, you can, if you just use the formula directly, you can reach this step in one line. Okay, good. Then you just make cosine theta, make theta the subject by bringing the cosine over. You get cosine inverse of this. Okay, then you get an angle around 0.2257 degrees. Round off to 1 dp, it will be 0.2. Can?
Can.
Okay, now take note. Sometimes they will tell you, sometimes this value over here, if it's negative, and then the question asked for, and the question asked for acute angle. What do you need to do? You have to modify the formula a bit, so it becomes cosine theta of modulus of 32 divided by square root 14 square root 77. Can?
Oh, modulus.
If they ask for acute angle, you better modulus. Because what's the other case? Let's say that cosine theta else, you are finding the obtuse angle. Because let's say, for example, your cosine theta ends up being a negative, I don't know, 1 over 2. Then what will theta be? If you remember your trigo. Can you just cosine inverse negative half? Is that what you're supposed to do? Cannot. Whenever it's just a negative, you need to find something called the what?
The
basic angle. Very good. Yes, you need to find out your alpha, right? Remember alpha? It's cosine inverse of the positive angles, positive number. So negative half, you ignore the minus, just put down a half. Cosine inverse half, then you get some angle. Let me just quickly check on my calculator. I'll change it to degree mode, and then I cosine inverse half. I obtain what a coincidence, 60 degrees. Then from here, when cosine is negative, you remember your ASTC?
I forgot already.
Add sugar to coffee, all science teachers are crazy. You forget already.
Yeah, the A math I forget already.
笑了till COVID. ASTC. Okay, what you need to know is that cosine is negative, but the angle that we are discussing in H2 math for dot product, theta will always be in between 0 degrees and 180 degrees. So we are only interested in these two quadrants, right? Remember, please remember, your angle starts from the anti-clockwise, right? Like this.
Yeah.
This one still can remember. So it's either these two quadrants, but if it's negative, which one would it which quadrant should it be in?
The third or fourth.
Cosine is negative. Our theta here is restricted to quadrant 1 and 2. So you should not be looking at quadrant 3 and 4 at all. Oh, that's a rule. Okay, so can you try again? Is it quadrant 1 or 2?
1.
Cosine is negative. Why do you say 1? Wrong. Should be 2.
Huh?
If cosine of theta is a negative half, the angle theta can only be in quadrants 2 or 3, correct?
This
Right?
one
A means all positive. C means only cosine is positive. Here we have negative, so it must be quadrant 2 or quadrant 3, right? Right? A max. Really forgot.
Yeah.
Did I explain something wrongly? Are you confused?
No. I just remember only.
Okay. Yeah, but then quadrant 2 or 3 is not what quadrant 2 or 3, that's the conclusion. However, this is a rule you need to memorize, which is that the angles in vectors are only in between 0 and 180 degrees. Sorry, inclusive. So that means that, can you have quadrant 3 angle?
Cannot.
Cannot, right? This will exceed 180. It will be in between 180 and 270. So that means that you have to be in quadrant 2. Oh, so that means that, how do you find our theta? Oh, your trigo, forget everything already.
Yeah.
How do you find theta? From the basic angle? A max.
Is it 180 minus 60?
Correct, yes. Okay, good. Then that's how you get the angle. If you get cosine to become a negative, you find theta, you need to do basic angle first, then after that you solve for theta. Oh, cosine inverse the positive, throw away the minus sign. Okay, maybe I should write that down. Throw away the minus, the negative, before you take cosine inverse.
So it's for all. Even the sign also throw away the
Yes, correct. Later on, when we look at vector product, first step is to find your alpha. Basic angle. You look at negative, you throw away. You focus only on the positive number, then you take cosine inverse. Then you get some answer using calculator. Then to find your theta, you must think about your ASTC. Just focus on quadrant 1 and 2 lah. Then it's definitely, because it's negative, it should be in quadrant 2. Can? Okay, can. If it's obtuse angle. Okay, if the question asks for obtuse angle. Okay, moving on. Wow, 40 minutes. Okay, too slow, sorry. Special angles. We're gonna look at different angles. So we know the formula A dot B is mod A mod B times cosine theta. I'll just write it down here. Let's delete this. What do you notice? If theta is 90 degrees, you have A dot B equals to 0. Or actually, it goes in both directions. Meaning you can start from the left and you get the right, or start from the right and you get the left. Okay? You start off with, the angles are 90 degrees. What can you conclude straight away? A dot B is 0. If you start with, I realize I dot the product of two vectors and they happen to coincidentally be 0, then I conclude that they are right angles. Why is this true? Very simple formula. You see theta equals 90 degrees. What does it mean? Sub in theta with 90 degrees. Over here, I show you the working. What happens when theta is 90 degrees? Cosine 90 is?
0.
0. So 0 times anything becomes a 0. Understand?
Yeah.
Now you must memorize this idea. Very important. Perpendicular vectors, dot product is 0. Perpendicular vectors, dot product is 0. What is 0? Dot product is 0, not cross product. Dot product is 0. What kind of vectors are they? Perpendicular vectors. Give me a geometrical interpretation when you find out the dot product is 0. They are perpendicular. So hide again. So now I hide it. Can you tell me again? What's the conclusion? A dot B equals 0 means the vector A and B are
perpendicular.
If they are perpendicular vectors A and B, what can we conclude?
The dot product is 0.
Very good. Okay, must remember. Okay, then point 2. What happens if it's 0 degrees? 0 degrees means it's what? Means it's parallel vectors. Okay, so here's a vector A, pink color. Then here's a vector B. In addition to being parallel, they are also in the same direction. right? So that's what it means when it's 0 degrees. Another interpretation, if it's 180 degrees, means vector A, sorry, maybe I should write down theta equals 0 here and draw a line to separate. Okay, then next diagram, I have vector A, I have vector B, but this time it's in the opposite direction because 180 degrees, right? Then this one would be, what's the interpretation? They are opposite vectors. They're pointing in opposite direction because you turn 180. Make sense? Okay, you need to know this. Perpendicular, parallel, opposite. They will test you one. Just took a look at the 2019 paper. Okay, moving on. Any questions?
No.
No. Okay, next one. Special case. When you got two same vectors, A dot A, you become modulus of A square. Do you know why?
No.
What's your theta here? If they are the same vector, what's the theta?
Like 0.
Exactly. Theta is 0 degrees. So you can just sub in into the formula here. Sub in, how the B become A. B becomes A. Then theta becomes 0. What's cosine 0?
0.
Wrong.
1.
1, yes. So let's sub in the formula. A dot B, sorry, A, it becomes A dot A, which is modulus A times modulus, not B, it's A, times cosine of 0 degrees. Cosine 0 degrees, you tell me is 1, right? 1 times anything can just throw away the 1. Modulus A times modulus A, that's what you get over here, modulus A square. You can square because now it's a number. By the way, you don't square vectors. Vector square is illegal. No such thing. You can only take the modulus of A, then square it. And you can only introduce modulus if you're quoting the formula. That's how you introduce modulus. Can?
Can.
Okay, moving on. Arithmetic, I think you know this. Basically, if you got a scalar multiple lambda in front of a dot product, you can put the scalar, you can times into the first vector, and then you do dot product, or times into the second vector, then do dot product. Both are fine. Okay, so like for example, you got a scalar 2, you got a vector 1, 2, 3, and a vector 4, 5, 6. What I mean is you can times the 2 into the first vector, then take dot product like this. Or you take the 2 times into a 4, 5, 6 to get this, and then you take the dot product. All three are equal. Okay? So the scalar can move around the vectors. It's like a ghost. Can go in, can go out. Okay, then how about the lambda? If you got a bracket around the sum of two vectors, you can distribute. Right? You know distribution, no?
Yeah.
Can I don't elaborate more? Then here, same thing. You got two scalar but one vector. You can also distribute. Okay, then A dot B is the same as B dot A. You can juggle them around. Can juggle. I give you a clown. What does a clown do?
Juggle.
Juggle. Why do I say juggle? Because A dot B and B dot A, you juggle the two terms around. Left go to right, right go to left. They are equal. Can you remember this?
Can.
Okay, a bit like 2 plus 3 is 3 plus 2. You can swap around. We have a technical name for this. It's called commutative. If you are not studying maths, you don't need to know this ever. Just good to know. Just juggle. Remember the clown can already. 2 plus 3 is 3 plus 2. A dot B is B dot A. Can? Okay, that's for dot product. Later for cross product will be a little bit different. You need an extra minus sign. Okay, then another 2 more points. If A and B are non-zero and non-parallel to each other, then we can say that lambda A equal mu B means that the scalar, the scalar that you multiply, they must both be equal to 0. That's the only way. And also, if you got extension, you add on a beta times vector B, and then you add on a mu times vector B. Sorry. Okay, if you start off with this guy, alpha times vector A plus beta times vector B equals to lambda times vector A plus mu times vector B. A bit like complex numbers, you can compare real, compare imaginary part. Alpha here, lambda here, they are the same. Beta here, mu here, they are the same. Okay?
Okay.
Let's compare. Can Good. And also keep in mind sine rule and cosine rule. Occasionally, you need to know them. You need to apply in geometry questions. Dot product and cross product. Can?
Can.
Okay, that was the primer on dot product. Primer summary on dot product. Let's quickly move on to the cross product. Okay, I use my hand as a model. I'll explain later. So cross product and vector product, they are the same names for the same thing. Why is it called a cross product? Because you see a crossover here. Why is it called a vector product? Because at the end of the day, what will you get after you cross a vector A? You still get a vector, not a scalar. So here's the formula number one you must memorize. A cross B is modulus A times modulus B times, is it cosine or sine?
Sine.
Sine, very different. Times, this one is what we call a unit vector with a head, right? Unit vector. So this is just to provide direction. It's to provide direction. Just notation. Huh? And it's a length one. Length one and provide direction. That's all.
Okay.
And also, maybe I should take note, it's perpendicular. The direction is perpendicular to vectors A and B. Okay?
But
Important
it will
point.
be one.
And the length will be one because I put a head here. Head means length one.
Okay.
Why is this important? Because later on you need to use this to find the equation of a plane. Do you remember? R dot n equals to some number.
Yeah.
R dot let's say 1, 2, 3 equals to some number, let's say 5. This is the equation of a plane, right? How do you find this n? You need to use this. You need to do cross product.
Oh.
Like if you have a vector here, you cross it, you'll get A cross B. Then this will become your normal. You know this, right?
Yeah.
This one just recap. I think this one is a very important point. Equation of plane. Or more specifically, it gives you the normal of the equation of a plane. Yeah, so next formula you must memorize is A cross B is if let's say A is A1, A2, A3, and vector B is B1, B2, B3, you'll get this formula. Do you need to memorize this in this format? I will say that this format is no good, but you do need to memorize it. I'll show you, I'll explain later. But before I go into the explanation, the elaboration below, let me show you a picture first. You need to keep this picture in mind. Here is a plane. You have a vector A and vector B sitting on it on the same plane. Now we're going to take the cross product. What happens? You need to do something called the right hand rule. Imagine your hand here is vector A, your palm inside, there's a vector B coming out. Then the vector A bends towards the vector B, right? Because that's how you close your right hand, I assume. Right? So the A moves towards the B. What happens to your thumb? It's pointing up or down. Then that will be the resulting direction of A cross B. If you're in physics, this will matter, but if you're not in physics, it doesn't really matter. What you need to realize is that after you take cross product, you will have a certain direction. Let's say for example, it's up. But what happens if you do B cross A? You just need to turn your right hand 180 degrees. Take your wrist, the wrist of your right hand, you turn it 180 degrees. You notice that your thumb will be pointing downwards. I don't know how to draw. Right? Your thumb is pointing downwards. Then your B will be here, your A is still here, but you just imagine curling your arm, curling your right hand. Your B will move towards the A. Right? Sorry, I didn't prepare a photo beforehand. I think you can visualize, right?
So is B cross A, then it's turn.
Then it will go downwards because your thumb is now bending downwards, which means that it is A cross B, but with an extra minus sign. Does that make sense?
Yeah.
So it's minus A cross B. Of course, this is exactly equal to B cross A. Can remember this? There must be a minus sign when you swap the order. So here, you cannot clown around when you're doing cross product. No clowning around because you cannot swap the order. The moment you swap the order, extra minus sign. But you can use this to your advantage if you need to, if you want to swap the order. Just take note there's an extra minus sign. Okay, now to give you a recap on how to remember this funny formula. A2B3 minus B2A3 minus bracket A1B3 minus B1A3, and then A1B2 minus B1A2. Okay, here is how you remember it. I never memorized that formula. I remember this pattern instead. Let's say you start off with two vectors, this one, then you want to use this formula. I labeled this is equation 1, equation 2, and then equation 3. How do we get number 1? Here's how you do it. To get row number 1, you strike off row number 1. Can you see? Purple color. Strike off the A1, B2. Then you do green arrow minus blue arrow. Downwards minus downwards from the left and downwards from the right. Like this. Can you visualize? This direction? So it will be, if you go downwards in this direction, it will be A2 times B3, right? To get row 1, you chop off row 1. Then you do green arrow minus blue arrow. Green arrow here means you do A2 times B3. Blue arrow here means you do B2 times A3. Of course, it's the same as A3, B2. Then after that, you minus. That's how you get row 1. Okay? Maybe it's not clear now. Later I'll give some examples. Then next one, how do you get row number 3? Focus on row number 3. Same thing, but this time to get row 3, you chop off which row? Purple color. What, row 3, to obtain your row 3 in the final answer, A1B2 minus A2B1, you chop off row 3. Make sense?
Yeah.
Then after that, you do down minus up. Again, same arrow. So what's down? A1 times B2. What's the other from the right left? Then what's the down from the right? It's B1 times A3. So B1 times A2. So that's how we get this formula. Make sense? Okay, good. This equation 1 and 3 are easy, but the middle one is a bit challenging. Here, there's an extra minus sign. Notice that?
Yeah.
Extra minus, please remember. So how do you get the A1B3 minus A3B1 first? Sorry, let me drink some water. Okay, yes. Sorry. Yeah. So how do you get a row 2? What you need to do is you strike off row 2, purple color. Then you do down minus down, from the left, from the right. A1B3 minus B1A3. Green arrow minus blue arrow. Can you remember?
Okay.
But then include extra minus sign. Then that's how you get the conclusion. Okay, let's just do some quick practice examples. Maybe I will do it at the summary on top. Let's do a quick example. Give me some numbers you like. After 0.
1, 2, 3.
Okay, 1, 2, 3, and I'll put a 4. So how do we get the cross product of this?
You strike off the first row.
Okay, let's strike off the first row. What do we get?
Then it's 0 times 4 minus 2 times 3.
Very good. Or 3 times 2, same thing. I like to think of it like this direction. So I just read off 0 times 4, 3 times 2. 0 times 4 minus 3 times 2. Or 2 times 3, same thing. Next one. Let's say we do row 3 first. Row 3 first. Easy.
Then I strike off the 3. So it's 1 times 3 minus 0.
0 times 0. Okay, I'll just put in to be more formulaic. Then row 2,
must put the negative first.
Negative first.
Then it's 1 times 4 minus 2 times 0.
Just strike off row 2. 1 times 4 minus 2 times 0. Correct. Well done. I'm sorry.
Okay.
Ayo, yeah. Need more water. Hold on a sec. Okay, yes, so that is the cross product. Then that is the formula version. Just keep that in mind. Formula number 1, formula number 2. Okay, recap again. Formula number 1, what is it? A cross B is modulus A.
Or modulus A, modulus B, or cosine theta for the dot product.
Sorry, for what?
For the dot product.
We are wait.
Oh, I thought
we
you
are
asked
currently
for AB.
we are currently at the cross product. Can you tell me the formula for cross product?
Oh,
again?
Modulus A times modulus B times sine theta.
Sine, not cosine.
No,
Sine,
that one is for the dot product.
That one is for dot product. Well done. Yes. Please remember, cross product is sine. Okay. And then don't forget there's a direction vector. But usually you won't need to deal with it. You will deal with the modulus of both sides, which means that this direction vector will disappear because we are just interested in the length. Magnitude means we are only interested in the length. Later on, I'll talk more about it.
Okay.
Okay, anyways, moving on. Perpendicular length. You need to remember that the cross product will give you perpendicular length. Why? Because you see, you involve sine theta. So means opposite over hypotenuse. What's opposite? This one, no? Correct or not? Theta, opposite. So it's always referring to perpendicular length. Must memorize, cross product is associated with perpendicular length. And here is the formula. Okay? Instead of a dot product, you change it to a cross. Can you see? Change to a cross. Do you want the derivation?
Don't need. Can memorize, right?
Yeah, can. But to be honest with you, I rarely use this formula because too many things to memorize. Usually you can avoid using this formula. It's only when they ask you what is the geometrical interpretation, then you better memorize. Dot product, shadow. Cross product, perpendicular length.
Oh,
Okay.
okay.
Don't call it shadow. Call it length of projection. Be more professional. That's a formal name.
Okay.
Okay, then number 4, just to be symmetrical with the notes from before, we also have an angle between vectors, but here I tell you it's not relevant for cross product. Okay, so we skip number 4. Then point number 5, special angles. You notice it's the same as the dot product discussion just now. Here, more formulaic, I put down theta 0 degrees, 90 degrees, 180 degrees. So again, it's parallel, perpendicular, opposite. But here is the relevant formulas. Basically, I'm just taking this formula. I sub in my theta with different values. I hope you know the values of sine theta from the sine graph. So what is sine of 0 degrees?
0.
So that's why over here, if I sub in theta with 0, I will get a 0 for sine theta. 0 times anything just becomes a 0. But take note, there is a vector here. Okay, so A cross B when theta is 0 degrees will give you 0 vector. How about when it's 90 degrees? Sub in sine 90, what do you get?
Also 0.
Your trigo 180. Did I do something wrongly? I don't think so. Yeah, so now can you tell me what's sine 90?
1.
It's 1. Very scary. Okay, not 0. 1. So you just get a 1. So 1 times anything, just left with the anything itself. So that's how we get A mod B. Sorry, I forgot to include one more. N hat. Oh, the vector n hat. So that's what you get modulus A times modulus B times n hat. How about when theta is 180 degrees? Sine of 180 degrees is?
0.
0. Very good. So this one becomes 0. So, let me think. Is it 0? Oh, you're correct, actually. Let me think a little bit. Okay, I might have written something wrongly. That's not correct. But it's opposite. Let me think. Sine of 180 degrees is 0. Yeah, you're correct. Okay. Yes. So it should be a 0 vector. But because sine of 180 degrees is equals to 0. But then, what you realize is that if it's 180 degrees, if you visualize what's going on, that's vector A, that's vector B, right? 180 degrees. So that means what we have now is the same. Yeah, correct. Okay, no. I'm making this too complicated. Let me just get rid of this. No, yeah, it's just 0 degrees. That's all. Yes. Whoops. Sorry. Made it too complicated. Yeah, it's just 0 degrees. Don't need right hand rule. Forget it. Yeah, so here's how you can interpret it. Maybe I should get rid of this. Actually, no, that's important. Okay, the main point that I want to drive over here is that opposite vectors and parallel vectors, right? Opposite is really just a special kind of parallel vector. Do you agree?
Yeah.
Because they just need to make sure your scalar multiple of it. Here, the scalar multiple is -1 or -2, right? A negative scalar. That's why you change direction. So it's just a parallel vector. So what you realize is that when theta is 0 degrees, which means they are in the same direction and parallel, when it's 180 degrees, which means they are in opposite direction but still parallel, both of them will give you what conclusion when you cross product?
0.
0 vector. So the conclusion here is that whenever you got two vectors cross product equals to 0 vector, it's the same as saying that these vectors are parallel. Is that okay?
Oh, so I must write the line below the 0 also.
Yes. It's a 0 vector. Meaning like for example, 1, 2, 3 times 0, 0, 0. Okay, what do you get? I mean, if you just quickly calculate, what do you get? You'll just be 0 minus 0 minus 0 minus 0 and then 0 minus 0.
Oh.
So it's a 0, 0, 0, which is not just 0, it's 0 vector.
Oh.
Yes. Maybe this example is not so good. I'll come up with a better example later and I'll update this. Okay. Cross product to give you 0 means that they are parallel. Wait. I can just quickly come up with an example. Let's say I don't know, let's say I times 2, so it becomes 2, 4, 6. Let's quickly check what's the cross product. What would it be? Row 1, strike off row 1, this direction. So 2 times 6 minus 4 times 3. Yes?
Yeah.
Next one, negative square bracket.
1
Right.
times 6 minus 2 times 3.
Which is 6. Okay, maybe I write down the working. I show the working. Minus 1 times 6 minus 2 times 3. Then the last row, strike off the third row.
Is 1 times 4 minus 2 times 2.
Okay, very good. So simplifying, I think you will get 2 times 6 is 12, 4 times 3 is also 12, 12 minus 12 is 0. 6 minus 2 times 3, 6 minus 6 is 0. Negative 0, still 0. 1 times 4 is 4, 2 times 2 is 4, 4 minus 4 is still 0. 0 vector. And I think you can tell that they are parallel, right?
Yeah.
Just times 2. So that's a geometrical interpretation. Cross product is 0 vector, you get parallel vectors. Can?
Can.
You can try this with other examples. You'll realize you always get 0, 0, 0 if they are parallel. Wow, don't you find that amazing? Okay, never mind, whatever. Not important. Just memorize the conclusion, can already. Point number 6, same vectors. Whenever you got 2 same vectors, well, they are really just parallel as well, right? Here's vector A. Here is also vector A. You can think of them as parallel vectors, right?
Yeah.
So that's why you also get a 0 vector. Because A is parallel to vector A. Okay, you're parallel to yourself. Okay, so 0 vector. Okay, then arithmetic. This one quite simple. But basically, I times I, when they are the same vector, it's also 0 vector, as what we've concluded in point 6. Then A times B is negative B times A. This is actually not repeat. This one is actually what I call right-hand rule, right? Right-hand rule. I show you the diagram just now. Because you turn your wrist upside down 180 degrees, your thumb starts to point downwards. So it will be opposite from before when it was pointing upwards. So you have an extra minus sign. Then lambda A times cross with lambda vector B. This one it's telling you that you can actually do your cross product first, then you multiply by your lambda, or your lambda can times into your B first, and then you multiply by A. But take note, you notice the only thing that's moving here is lambda. Lambda is on the left side, or lambda is in the left, or lambda is in the right. The A and B, did they swap position? A on the left, B on the right. A on the left, B on the right. A on the left, B on the right. Did they swap position?
No.
No, because very important point. Do not swap positions of vectors A and B. Oh, 10 a.m. already. Sorry, I'm going a bit too slowly. Haven't covered example questions, so sorry. Still on theory. Then here, the last one is basically you can distribute. Distribute. Also take note, must read from left to right. A times with B, you better write down A times B. Don't suka just change it around to B times A. Because cross product order matters. Order matters, no juggling. It's a bit like matrices. One. Okay, I shouldn't give such a complicated example. Let's say 2, 1, 0, 2. Okay, then you matrix multiply with, I don't know, 1, 2, 3, 4. It will not be the same as 1, 2, 3, 4 multiply with 2, 1, 0, 2. Remember from EMAth? The order, you cannot anyhow swap. Same thing over here. Vector product also cannot anyhow swap. Okay? You'll get A times B plus A times C because A goes in. And then A times B is actually just a negative of B times A. Can? Okay, good. So this one, to be honest, dot product and cross product, these properties, right, it will only appear in those proof questions which are a little bit more difficult and challenging. So I have prepared some questions for you as homework. Later you'll get to see. Let me just get my charger. Sorry about that. Let us continue. Okay, so now, finally we reached vector equation of a line. So there are 3 forms of the equation of a line. vector form, parametric form, this triplet, and Cartesian form. Okay, so let me elaborate. How do I get this vector equation of a line, the intuition? What you do is you have a line. You must think about it in terms of starting from the origin. How do you reach a point on the line? Like you see, a line is just an infinite number of points. Infinite number of points. And you want to represent them with position vectors. So you start off with origin. How do you reach the point? How do you reach the line? One suggestion would be, if I already know a point A on the line, I can just directly travel from O to A. Right?
Yeah.
Or maybe I start from a blank canvas, then you can see better. I start off with a point O, and then I want to reach the line. So let's say I already know there's a point A. So I can just travel from O to A. Agree?
Yeah.
But now let's say I want to reach to vector B1. Point B1. How do I, but I started from origin, I move to point O. Sorry, I start from origin and at point O, and I move to point A already. How do I travel to B1? In other words, I want to find OB1. Wouldn't it be just vector OA, you add on AB1?
Yeah.
Correct, right? But now let's say I change it to, I move it over here, then I label it as B2. What would change now? Instead of AB1, it will be AB?
Plus AB2.
AB2. Of course, you can repeat this exercise for any other point. How about here, B3? How about here, B4, B5, B6? Let's say, for example, over here. Many points, B3 here. Then what will happen to this point?
B3.
B3, okay. But now we want all the possible points. So B1, B2, B3. Can we keep on listing down everything? Cannot. So what's a faster way? Faster way is we need to introduce something that I like to call the direction vector, denoted by B. This direction vector is keyword, P word. What do you think is a P word? Pair.
Huh?
Can you think of the adjective to describe this?
Oh, it's parallel.
Parallel, keyword, parallel, must remember. Parallel to the line L, okay? Vector B is parallel to the line L. Then what we can do is to realize that, this B3, isn't it just like 2 copies or 1.5 copies of this vector B? Right, you see, from A to B3, isn't it just 1.5 times of a vector B?
Yeah.
Or if I move my B3 to another point, B4, then you realize that if I want vector OA plus vector AB4, then that means my AB4 is now not 1.5 times of vector B, it's 2 times, right? 1, 2. Right, let me I draw 2 for you and move it over, right? Roughly 2. Okay. So that means that in general, if you keep on moving the points to all the other points along the line, it's really just some multiple of this B. So that's why I can change my 2 here into, in general, a K. Does that make sense?
Yeah.
So in this case, if you have another vector B, this one will be K equals to 2. Of course, in general, that will just be the vector equation of the line already. So in general, if I want a generic point, let's say P, I can represent it by a generic vector R with a tilde below. Please, I saw your notation. You write down R already, then you never write a tilde. Not very good. Must have a tilde below.
Okay.
It will be equal to OA, which I like to simplify as just a little a with tilde below, plus lambda times of vector B. Okay, I choose to use the letter lambda of convention. Okay.
Okay.
So that's the equation. That's how you get the vector equation of the line. The notation is you put down the name of the line. L, sometimes it's L1, sometimes it's capital L, sometimes capital L1, capital L2. Then you put a colon, dot. And then you put down the generic vector R with a tilde below, equals to A plus lambda B. Okay? I think you know this. I saw that you definitely know this. I saw that you were able to do it. Just think note that B is direction vector, which is parallel to line. And OA is has A being the point on the line L. Okay, moving on. Now we move on to the parametric form. Parametric form is very simple. All you need to do is to look at your vector R, right? Then you rewrite it. Vector R, is in general some generic point, so X, Y, Z. I strongly recommend that you do not write down X, Y, Z unless it's absolutely necessary. Always write down generic vector R. I saw in your working, you wrote down bracket X, Y, Z equals to A plus lambda B. Don't do that. No. Only do this when you're trying to convert into parametric form. When they give explicit instruction, please convert into a parametric form. Then you do this. Clear? Okay, but here's the theory. If you substitute R with XYZ, you know it's A plus lambda B. But vector A is nothing but a column vector, right? So A1, A2, A3. Same thing with vector B, the direction vector. Some vector B1, B2, B3. Then you can just add them together. Lambda times in, times in. What will we get? We will get A1, A2, A3 plus, this time the lambda goes in, so it becomes lambda B1, lambda B2, lambda B3. Then you can just add them together. So A1 plus lambda B1, A2 plus lambda B2 for the second component, A3 plus lambda B3. Sorry for my handwriting.
Okay.
Yeah. Then you get a vector. So now you got X, A1 plus lambda B1. Y is A2 plus lambda B2. Z is A3 plus lambda B3. Compare component wise. That's why you get these three equations. Clear?
Yeah. Okay.
Okay, next one, Cartesian form. Cartesian form is very simple. Let's say you start with Cartesian form. They give you x minus a divided by some number, y minus a divided by some number, z minus a divided by some number. You always make sure you equate to lambda first, then you just solve for x. So I think it's better if I just give a quick example. Let's say you got x minus 1 over 5 equals to y minus 2 over 5 equals to z minus 3 over 5. How do you convert it into the vector form? Here's the strategy. You always start off with this guy equate to lambda. Second guy equate to lambda. Third guy equate to lambda. Can?
Can.
Then you solve for x. So x in this case will be 1 plus 5 lambda. Y equals 5 times over, so it becomes 5 lambda. You got minus 2, bring over, become plus 2. So 2 plus 5 lambda. If I make your life difficult and I change this into a plus 3, what would it be? Z equals?
Oh, Z
Z equals?
Z equals to -3 plus 5 lambda.
Very good. So now you got x, y, z. Then you can just combine them together. Generic vector R is just x, then y, then z, right? So you can substitute in each one. So you get 1 plus 5 lambda, 2 plus 5 lambda, -3 plus 5 lambda. Then you can split them up like this. 1, 2 minus 3 plus 5 times of, sorry, plus lambda times of 5. Is that correct?
Yeah.
Lambda times of 5, 5, 5. Yes, actually you could have changed this. Let's say I change this to a 4. And here will be a 4. Here will be a 4. And here will be a 4. And here will be a 4. It changes accordingly. Make sense?
Yeah.
And that's a vector equation of a line already. Can?
Can.
Okay, take note that sometimes there will be examples where they give you one constant like this. In this case, like for example, let me just give a quick example. Oh my goodness, no space. Let me bring it down. Another quick example, let's say you got x minus 1 over 2 equals to y minus 5 over 7. And then they give you z equals to 9. What you do is work with the z equals to 9. Think of it as z equals to 9 plus 0 lambda. Okay? Constant plus some scalar times lambda. And likewise for this other guy, it will be, if you equate it x minus 1 over 2, you equate to lambda, then you solve for x, you get 1 plus 2 lambda. Second guy, if you equate to lambda, you get y equals to 5 plus 7 lambda. And then now you got x, y, and z. Combined together, what do you get? Can you see straight away? That it will just be
159 plus lambda 270.
very good. Okay, so you know this, Can I actually saw you are able to get the correct equation in your working. Yeah, when it's an equal sign. Don't have a fraction, right? This is a special case where there's no fraction. Is this clear? Convert the Cartesian the Cartesian form?
Yeah, so it just has no lambda.
Yeah, correct. 0 lambda. There's a plus 0 lambda.
Okay.
So it becomes a 0 here. Okay, that's converting from Cartesian into vector form, but you can also work backwards. Do you need me to show you?
The backwards one, I think so.
Okay, can. So basically, how do you start from here and you convert into this format?
Mm.
Can you see that you can just do it in one line?
One line.
X minus away 1. See, how do you get x minus 1 over 2? X minus 1 over 2. 1 here, 2 here. Then y minus 5 over 7. How do you get a 5? How do you get a 7? Minus away the 5, divide by the 7. Maybe, and also the last one is z. It's this one you can interpret as z minus 9 equals z minus 9. It's just z minus 9. Oh, you can think of it like you minus away a 9. Then you divide by 0. But cannot divide by 0, so you don't divide by 0. So equal to 0. So if that's a bit difficult, never mind. I show you another way to do it. Let's say we start off with this fella here. Now I want to convert into a Cartesian form. Maybe I should write down instruction. Convert L into Cartesian. Okay, that's the instruction. How do we do that? Let us see. So what you can do here is, you know that if there's a 0, you leave it alone. If it's non-zero, what you do is you substitute the r with xyz. This is the only time when I write down xyz.
Mm.
In all other cases, please only write down a vector r. And then you just add them together. You get 1 plus 2 lambda, 5 plus 7 lambda, 9 plus 0 lambda. So x is equal to the first component. So I conclude x equal 1 plus 2 lambda. Same thing. What is y? Y equals to?
5 plus 7 lambda.
Very good. Then the next one, last one?
Z is just 9.
Z equals to 9. Oh, then that's it. You can leave the z alone. But the others, you can make you can make lambda the subject. Can you see? If I bring the 1 over, I'll get x minus 1 equal to 2 lambda. Divide by 2, then I get x minus 1 over 2 equals to lambda.
Yeah.
Likewise, I can do y minus 5 equals 7 lambda. So y minus 5 divided by 7 is equals to a lambda. Lambda, lambda. If they are equal, you can simplify both of them together to get you x minus 2 over 2 equals to y minus 5 over 7 equals to lambda. Don't need to write equals to lambda. And z equals 9. There you go. Done. Easy?
Yeah.
So here, the trick is, maybe I should write this down. Vector into Cartesian make write down a short procedure. Sub r equals to xyz. Then get 3 equations. Then make lambda subject. Right? That's basically a description of what went on. Right? You substitute the r with xyz. Then you get 3 equations. X equals to 1 plus 2 lambda. Y equals to 5 plus 7 lambda. Z equals to 9 plus 0 lambda. You get 3 equations. Then make lambda the subject. That's exactly what I did here. Right?
Okay.
Then you conclude. Okay. Then, of course, the other direction, I think you, do you need me to write down a procedure?
Don't need.
Don't need, Okay, I think this one is obvious. You just have to equate them to lambda, then solve for x. Right? Equate to lambda, solve for x, solve for y. Okay, this one a bit special. You must add on 0 copies of lambda. 0. Okay, moving on. 3 forms of vector equation done already. We can move on to the points you need to know about equation of straight line. Point number 2, intersection of lines. So there are 3 types of lines. The relationship between lines: parallel, coplanar, or skew. So let me give you some examples. I didn't leave enough space for me to draw. Hold on. Okay, I'm gonna move everything down. I need more space. Wait.
Okay.
You need to leave by 12 p.m. is it?
I don't need.
Okay, continue. Can. Okay, so let's see. Point number 1, parallel. So parallel vectors, right, is basically saying, if let's say you got a vector, parallel line, means that you have a line L1, you have another line L2. The key thing is we don't look at, and let's say it passes through a point A, passes through a point P. Okay, I don't, let's say B, let's say B. Then the key thing here is that to prove that they are parallel, you focus on their direction vector. So let's say this is vector B. Let's say this one is vector D. Okay, what we need to do to show that they are parallel is to show that the direction vector is parallel. In other words, vector B is parallel to vector D, imply that L1 is parallel to L2. And if and only if. You probably don't know this notation, just you know this means it's equivalent to. Double arrow is equivalent to. Can?
Can.
Let me see my notation. D1, D2. Oh, sorry. Let me just change the notation. I don't want B, I want D1. D1 and D2. Okay, good. So that is the parallel lines. Then the next one, coplanar. What is coplanar? Coplanar means they are intersecting lines of parallel vectors and they both sit on the same plane. But the main point is that they intersect or they are parallel.
Oh.
Okay. So for example, you have a plane like this. And then you can imagine you have another plane that's slanted like this. Okay, actually this one a bit extra. I don't really need to draw this to understand coplanar vectors. You can imagine, right, two planes intersecting each other. It's like two pieces of paper cut each other.
Yeah.
Then you can have, okay, that's not very relevant. Let's just focus on one plane now, the bottom one. Then coplanar means they are both sitting on the same line, on the same plane, sorry. Like this and like this. Okay. Then what you realize is that here they sit on the same plane, but they don't intersect. But that's not true. Actually, what happens is that this plane is just that I drew it a bit too short. The plane actually extends all the way in all directions. Right? It actually goes in all directions. So this line, at first you might see they don't intersect. But actually, if you extend it a bit more, like this and like this, you realize that they intersect somewhere here. Correct?
Oh. But the parallel vectors, what's the difference between the first one and the parallel
intersecting line versus parallel vector. Okay, so parallel vectors, they will always be on the same plane. Because you see, no matter what line you draw, if you can imagine in 3D space, you can always draw a vector that contains it. Think about it. A4 piece of paper, you draw two lines. Then they are parallel. But if you keep on turning the A4 piece of paper around in space, those lines will remain parallel, right?
Yeah.
Or you can think of it the other way around. You start off with parallel lines, you can always fit A4 paper that contains both of those lines. You can turn it around. Do I need to demonstrate it in real life?
Don't need.
Don't need. Okay. Can. Yeah, so you just need to understand that parallel vectors means they are on the same plane. The next one, number 3, skew lines. This one means the definition of skew line means they are not parallel and not intersecting. Can you visualize in 3D space? What is skew line? Okay, let's say in 2D first, x and y axis. Can skew lines exist?
Cannot.
No. Yes, impossible. Do not exist. Do not exist in 2D. We are focusing only on 3D in vectors. We do not exist in 3D because you see two lines, they either intersect or they are parallel. Those are the only two possibilities, right?
Yeah.
So here, very funny, right? Not parallel and not intersecting. How? Let me show you a very simple example. Draw a cuboid. D&T class, I think you learned before.
Yeah.
Focus on this line and this line. What do you notice? Are they parallel?
No.
Are they intersecting?
No.
Ta-da, that's the answer. Skew line?
So it's only in 3D.
Only in 3D, yes, correct. This one is only in 3D, yes. Only in 3D skew.
Then the coplanar also 3D.
Yes.
Okay.
Yes. Planes are in 3D. Maybe another example would be like this. If you can imagine at the back, There's a vector like this at the back. So basically there's a plane in front, and then there's a plane, sorry. There's a plane behind, the rectangle behind, and then there's a plane that's in front. So they lie on different planes. Then that's when they are skew. Okay, can visualize?
Yeah.
But here, mathematically speaking, you need to prove, you need to prove that they're skew, right? The goal is to find a contradiction. You need to do a practice example, then you can do not parallel and not intersecting. Maybe it's a good time if I do an example. Let me just bring up the worksheet. Hold on a second. Sorry, give me a moment. Can you bring up your homework one? I sent it to you already. You have the file open?
Oh, yeah.
Okay, let me find the question that has the skew one. Let me search for it. Okay, let's take a look at question 15. This is vectors. Oops. Homework 1. Look at question 15. The vectors examples worksheet. Right? Vectors examples H2. Okay, question 15. Are you there? So let's read the question. For each of the following pairs of lines, determine whether they intersect and find the position vector of their point of intersection P if it exists. Otherwise, determine if they are skew. This is a very good practice because it covers everything that I've discussed about lines. So first one, you got a capital L1. Vector R, generic R, don't write XYZ, equals to 3, 1, -1 plus lambda times of 1, 2, 3. Oh, to be more precise, you should say lambda some element of real numbers. This is set notation, you know?
Yeah.
Element of the set of all real numbers. So it's just some real number, any number. Then L2, it will be x minus 2 equals y minus 5 over -1 equals to z. Here z. How come so special? Only z, no fraction. What you need to know is that you can rewrite it as a fraction like this, x minus 2 over 1 and minus 0 over 1. Correct or not?
Yeah.
Then now, this one Cartesian form not useful. What should you do? Always convert into vector form. Vector form is the best one. So how do we convert into vector form? Let's see. First guy equate to
lambda.
Same thing for all the other guys. I think you know this. I'll just do it for one. So I think you were saying, but do you want to say something?
Oh, no.
No, okay, so vector form, then solve for x. So x will now be equal to 2 plus 1 lambda. Y equals to 5 plus 1 lambda. 对不对? Minus, sorry, should be minus lambda. Z equals to 1 lambda. 0 plus 1 lambda, if you want to be more. Is this correct?
Yeah.
Can, so now we can combine them all together. Vector R will be your x, y, z. Actually, you can skip this if you can see straight away. Then just write down the components. X is 2 plus lambda, y is 5 minus lambda, z is 0 plus lambda, plus 1 lambda. Split them up into 2, 5, 0. Add on lambda times of, what do you see as the coefficient? 1, -1, 1. Okay?
Yeah.
So just to make make it look neater, I'm going to rewrite it as R equals. Oops. By the way, this worksheet, the questions, right, are too simple already. They're very direct. The questions in A levels are not that direct. So yeah, you need to make sure you can understand how to do all the questions in this worksheet, like without any trouble. Here, since we already use lambda, right, we should not recycle the lambda. Okay, we should use a different letter. So let's say I use mu. Okay, mu an element of real numbers. This one is mu.
Okay.
So it's lambda. Yeah, so now we got the two equations. What did they ask you to find out? Determine whether they
intersect.
So how do you do that? How do you find out if they intersect?
Is it equate both to each other?
Correct, exactly, yes. You got vector R, equate them, solve them simultaneously. Just like in secondary school when you got two lines, like y equal minus x plus 1, this one, y equal to 2x. You want to solve for the point of intersection. Just have to substitute. Y equals, then you can just say 2x equal minus x plus 1. Then solve for x. Then sub in, so you get y equals to 2/3. Then the coordinates will be 1/3, 2/3. Right?
Yeah.
Same thing over here, just that now we got 3 components, so a bit more long-winded. Still the same thing. Equate. So I'll call this equation 1, call this equation 2. To find the point of intersection, for POI, point of intersection, 1 equals 2. We equate them. So now we can get this fellow over here. Oops, sorry. The equation 1 equate to equation 2. So it's this other guy over here. Equate. I think you can see you can combine them into a single fraction like this. 3 plus lambda, 1 plus 2 lambda, minus 1 plus 3 lambda, correct?
Yeah.
Likewise for the right-hand side, maybe it's better if I just copy down the original form. Right, just now I already write down. Save some time. Oops, I meant to do that. Okay. The size a bit different, but okay, never mind. Compare component-wise. So 3 plus lambda equal 2 plus lambda. Oh, sorry. Did I write down lambda? I meant to write down mu. Can?
Can.
Sorry, I changed a lot of things. I hope you're not confused.
It's okay.
Okay, cancel 2 plus mu. Comparing x and what else you get? 1 plus 2 lambda equals to 5 minus mu. And minus 1 plus 3 lambda equals to mu. Then now we can see a bunch of equations, right? Lambda and mu, 2 variables. How do you solve a bunch of equations with 2 variables? Simultaneous equations, correct or not? So maybe I can rewrite it like this. Lambda minus mu equals to 2 minus 3. So lambda minus mu equals to -1, correct?
Yeah.
Equation 1. Okay, I already put 1, so maybe I'll call this 3. Then I can rewrite as 2 lambda plus mu equals to 5 minus 1. 2 lambda plus mu equals to 4. Equation 4. Actually, you got 2 equations you can solve already, right? So 3 and 4, solve them simultaneously. You know how to solve using calculator?
Yeah.
Can should I demonstrate? I can demonstrate here. I'll just do it.
It's the GC, right?
Oh, right. Yes.
The simultaneous equation.
Yes, correct. Let me see if I can share my fancy screen. Let me see. Okay, and then I need to click view, detach LCD, full screen, right click, window projector, share screen. Where's my window projector? Over here, I can see.
Yeah.
Can you see my GC? Okay, so here is the GC. How you do it is, right now we got 2 variables in 2 unknowns. So what we do is, let me just hold on. Second, quit first. Sorry, I was doing some working beforehand. I uploaded some videos on the playlist, by the way.
Okay.
Okay, so what you do is you click on apps, go down to poly simultaneous. I think it could be a different number on your calculator. Mine is number 6. Poly simultaneous equation number 2. Enter. Enter. Then you want to select simultaneous equation solver number 2. Then 2 variables in 2 unknowns. So 2 equations, 2 unknowns. Selected already, just nice. This decimal or fraction doesn't matter. Normal mode is okay. Float don't matter. Radian or degrees. Here we are not looking at trigo, so it's fine, doesn't matter. Press next. Then just key in. Do you know how to key in?
Yeah.
Oh no, why is my zoom in screen so small? Let me just. Oh, I need to click on the whole thing. How do I do that? How do I do that? Let me just figure out what's going on. Yeah, it was okay just now. How do I? Oh, you couldn't see what was going on just now, is it? Uh-oh, that's not good.
It's very zoom in.
Yeah, that's why. Let me just. Oh no, not prepared. Window projector is here, and then I need to share this window projector. Is that better?
Yeah.
Oh, okay. Let me show you again. Let me show you again. Second, quit. Oh my god. Yeah, so how did I access it? I press APPS, and then I scroll down to my poly simultaneous number 2. It's number 6 here. I press enter. And then I scroll, enter again. Then I select number 2 for simultaneous equation solver, enter. Then this is 2 equation, 2 unknown, so 2, 2. Then I press next. I press next. Then just key in. So my equation just now, if you copy down anything, it was a lambda minus mu equals -1. So 1 lambda -1 equals to -1. Okay, then the next equation was 2 lambda plus mu equal to 4. So 2, 1 equals to 4. Then I solve. I get 1 and 2. Huh? So it means lambda equals to 1 and mu equals to 2. So can I just change back to my iPad screen now?
Yep, okay.
Can so okay. Okay, back to the screen. Yes, so basically you need to focus on the coefficient 1, -1, -1, 2, +1, +4. Oh, right. You must make sure that the lambda is in the same position, and the mu is in the same position. You don't go and rewrite it. Don't blah blah and rewrite it as what mu plus 2 lambda equals -4. Then you key in 1 and +2. That will be totally wrong. You need to make sure the equations are in the same order. So maybe it would be better if I just copy down the equation top and bottom like this, so that you can see extremely clearly. Sorry for the handwriting, but I hope you can see lambda and mu are in the same column. Oh, so 1, -1, 2, +1, -1, 4. That's why I key in just now in the GC. Can? Okay, yeah, like this in the GC. In GC poly simultaneous number 2. Okay, so you get this 2 as your function, but wait, here we still got one more equation. Let's double confirm. Do we satisfy this equation? Satisfied? Check. LHS -1 plus 3 times lambda, but lambda we solve for 1. So what we get? -1 plus 3, which is +2. How about RHS?
Also
We
2.
solve for mu equal to 2. Since they are both equal, this means that confirm, correct. Consistent. That means that this is our actual answer. Huh?
So I need to check in the exam.
Have to check, yes. Because later on I'll show you skill line. You need to check that it's not consistent. I'll show you, continue in our example soon. So now let's answer the question. Yes, they do have a point of intersection. All I need to do now is to take either equation 1 or 2. Equation 1 here or equation 2. I just sub in my lambda or I sub in my mu. I will get my answer. So let me show you for equation 1. This is L1. Okay, L1. L1 here, I solve for lambda equals 1. So that means that let's just call this point P. Point P as the point of intersection. So vector OP would be equal to 3, 1, minus 1, add on lambda, which is 1, times of 1, 2, 3. What do I get? 3 plus 1, which is 4. 1 plus 1 times 2, which is 3. Minus 1 plus 1 times 3, which is -1 plus 3. So it's a 2. There you go. P is 432. Can?
Okay.
Let's verify with L2 as well. L2 in this case is just this equation here. Right? Over here. Equation 2. I'm just going to bring it down. Cut and scroll down and paste. This was my L2. Okay, sorry, let me scroll back up. I'll label here as L2, or over here as L2. Then I just bring it down. So L2, if I just sub in my mu equals to, what is it? Mu equals to 2, right?
Yeah.
So R is now vector OP, so 2 plus 2, 5 minus 2, 0 plus 1 times 2. What do I get? I get 4, 3, 2. What a coincidence, it's the same. Of course not, it's supposed to be the same. If you get something different, something is wrong. Okay, so yes, we answered the part 1 of the question, 15 part 1. We showed that they intersect. Now we want to find the position vector of the point of intersection P. Yes, which is what we did here. Otherwise determine if they are skew. Okay, so if they intersect, they cannot be skew already. Okay, because remember what's the definition of skew? Skew means you must be not parallel, not intersecting. We already showed it's intersecting, so we don't need to check for skew. Now let's look at part 2. It will be skew. Skew means not parallel, not intersecting. Let's look at part 2. This is question 15, part 2. Check that they are skew. So now we got L1. This time is R equals to, this time you see 2I minus J plus K. It's just 2 minus 1 and 1. So I can write down straight away 2 minus 1 and 1. Don't need to show working, just write down straight away. Then S times I minus 2J plus 2K. So 1 minus 2, 2, right? Then S an element of real number. And then you got L2. This time is R equals to, let me see, 1 minus 3, 4. I minus 3J plus 4K is 1 minus 3, 4. Plus T times of what? Can you tell me what's the vector?
2, 3, and -6.
Well done. Then T an element of real numbers. So first thing we need to check, remember skew line definition is number 1, not intersecting, and what's the second one?
And
not
parallel.
Okay, very good. So let's check that they are not intersecting. How? Again, you equate. R equal, so you just equate them. Vector 1, equation 1, equation 2, 1 equals to 2. Then we can, maybe I should write down. Check. Sorry, we assume intersection at point P. What does that imply? It means we can equate them together. Then we should be able to get a vector OP, which is our vector R. But the vector R is just 2 minus 1, 1 plus S times whatever, and 1 negative 3 T 1 negative 3, 4 plus T times of whatever. Equate them together. Can?
Can.
What we need to show is that they don't intersect. So we need to get something that we call an inconsistent system. Means we'll get a nonsense equation in terms of S and T. Let's see what happens. So just combine them quickly. So you get 2 plus S minus 1 plus negative 2S, 1 plus 2S. That's on the left-hand side. Right-hand side. Right-hand side is 1 plus 2T
Negative
minus 3
plus 3T.
and
4 minus 6T.
Very good. Equate them so you get. Let me show you iPad shortcut. Copy, paste, and then I'll just erase, equal. Okay, that's the main idea. Do this in real life, you have to write down step by step. Okay. So we get 3 equations. Now, I'm just going to call them A, B, C. So let's take a look at A. Simplify what we get. We get S minus 2T equals to, let's see, 1 minus 2, so negative 1. Right, 2 bring over, 2T bring over. Is that too fast?
No, it's okay.
Can then let's move on to part B then. So I get minus 2S on the left-hand side. I'm gonna bring like plus 3T over, so minus 3T equals to negative 3 on the right. Bring the minus 1 over, become plus 1. Minus 3 plus 1 is negative 2. Can?
Can.
Then you move on to part C. We get 2S leave alone. Minus 6T bring over, become plus 6T equals to 4. Bring the 1 over, 4 minus 1 is just a 3. Is that okay?
Yeah.
So now we try to solve this system. If you use GC, you have to select 3 equations, 2 unknowns. What will be the coefficients you have to key in? I think you can see it's a 1, negative 2, minus 1. Minus 2, minus 3, minus 2. 2, 6, and 3. Correct? Yeah. Then you just key in accordingly. What you will get at the end of the day is an inconsistent system. But I think using GC, then you can conclude inconsistent system, or you get no solution.
Oh, so that's why I write there's no solution.
You just write down no solution. And this implies that there is no POI, no point of intersection. How do you show that there's no solution? Manually. Let me show you. So maybe I'll just call this one. I'm running out of letters. Could I just erase away this? Okay, better not. I think I'm just gonna call this A prime, B prime, and C prime.
Okay.
Let's take B prime add on to C prime. What happens? minus 2s plus 2s.
So it's 3t.
3t equals?
So
Add them. Minus 2 plus 3?
One.
Just a 1. So t equals to 1 over 3. Now, let's say we substitute this into our, let's say, equation b prime. What do I get? Minus 2s minus away 3 times of t, which is 1 over 3, equals negative 2. Simplify. Minus 2s minus 3 times 1 third is minus 1 equals negative 2. Solve for s. Bring the 1 over, you get minus 1. Divide by negative 2, I get positive half. Can?
Yeah.
Let's see. Positive half. Okay, so now I got t equals 1 third, s equals 1 half. Which equation have I not used? A prime, b prime, or c prime? Haven't used. Which one?
The c prime.
No, I use here already. I use c prime.
A prime.
A prime haven't used. So what should we do with this t equal 1 third and s equal half?
Sub the A prime.
Exactly. So let's check what's a what we get. So s will become, so LHS of this a prime is s minus 2t. So s is half minus away 2 times of t. Sorry, I'm writing it slanted to save space because I'm running out. Okay, then half minus 2 times 1 third. Let's just type in a calculator. Half minus 2 times 1 third. What do I get? Negative 1/6. How about RHS? Negative 1. Eh? What happened?
It doesn't equal to each other.
This is what we call inconsistent. Because it's inconsistent, therefore no solution. Make sense?
Yeah.
As long as you get 2 solutions, it should satisfy all 3 equations. If at least one of them you don't satisfy, like you get this kind of nonsense, negative 1/6 equals to negative 1, then it means that there is no solution. If you don't like the manual way, I think using yes, you can just use the GC. Type in correctly, then you get no solution, then conclude no point of intersection. This one also okay.
Okay.
This one is the manual way. I just want to show you. Don't just trust the computer. I mean, you can do it manually. Of course, in exam purposes, you can just use the GC.
Okay.
Yeah. So that is no point of intersection. We are only done with the first half. So skew line you want to prove is very long-winded. Not intersecting done already. Now we need to show they are not parallel. How? This one easy. How do you show that they are not parallel? First, you need to think about how do you prove parallel lines? How do you prove parallel lines? Focus on which one? This one or that one? This one or that one?
The second one.
This one is, the first one is called the point. The second one is what we call the direction vector. So we look at, let's just call D1 to be 1 minus 2, 2. Sorry, let me change the color. One black. Okay, and then we call D2 to be the other direction of L1. And this one is 2, 3 minus 6 of L2. I think you can see that they're not parallel. So let's just assume that they are parallel. Then we can get something called a contradiction. If they are parallel, we can conclude D1 should be equal to K times of D2, right?
Yeah.
Some scalar. Some K an element of real number, a specific number. So what this means is we'll get 1 minus 2, 2 equals to K times of 2, 3 minus 6. If we try to equate them, what we'll get is 1 equals to 2K, minus 2 equals to 3K, and 2 equals to negative 6K. Agree?
Yeah.
Okay, good. So now we can solve for K in the first one. We'll get K equal to half. Now we can solve for K in the second equation. K equals to negative 2/3. Straight away, you see contradiction. How can K be equal to 2 different values? Impossible. K can only be one specific number. One specific number. Here is contradiction. So we conclude the initial assumption that they're parallel is false. So D1 is actually not parallel to D2, which implies that L1, sorry, I use capital. So I should be consistent. L1 is not parallel to L2. Okay?
Okay.
Find our inconsistent system. And since you are not, no point of intersection, you are not parallel. Conclusion is, therefore, L1 and L2 are skew lines. Finally, done. Shown. It is in your syllabus, so haha, learn this. You need to do quite long-winded. Okay, basically equate them, solve the system, you get no solution, therefore no point of intersection. To show, then you want to show not parallel. Take the direction vector, assume that they are parallel, so you can get d1 equal k d2. You get a bunch of equations. Solve for k 2 times. You'll see that they will be inconsistent at least one time. Therefore, you get contradiction. Contradiction means that d1 is not parallel to d2, so L1 is not parallel to L2. No point of intersection, not parallel, then you conclude that they are skew lines. Okay? Is that okay?
Yeah.
Can then I move on? Wow, okay. 11 already. I continue. Is that okay?
Yeah.
Okay. Can. So we're only at point 2. Okay, then the next one will be point 3 and point 4, and then point 5. Planes, I'll talk about it another day. I'll finish up this page. So next one, point number 3, you have angle between two lines. So if you want to find the angle between two lines, what you need to realize is that, let me just draw a picture for you. Here is a line, here is another line. You want to find the angle between them, it means you extend it a little bit, right?
Yeah.
You want to find the angle between them. Let's use red ink like this. What you should realize is that if you have a line that is parallel to it, otherwise known as a direction vector, let's call it D1. Let's say you have another line that's a direction vector D2. I'll try to make it parallel. I think does it look parallel?
Yeah.
Close enough. Then what you realize is that you can actually just treat the D1 and D2 as free vectors, so you can move it over, I don't know, anywhere. Same thing with D2, free vector, so you move it anywhere. Then take a look. If I move it such that the butt is the same position, the starting point is the same. There's an angle over here. What do you notice about these two angles?
They are the same.
They are the same. So that means in order to find the angle between two lines, I should label L1, L2. You just need to find the angle between the two vectors. Does it make sense?
Yeah.
Okay, that's exactly what I wrote here. Take the direction vector D1, D2 of each of the lines. Use the dot product formula to solve for theta. Remember? Dot product formula? How do you find the angle between two vectors? How do you find the angle between two vectors?
A dot B over modulus A modulus B.
Yes, over here, I gave you one example already, right? Assuming that this vector A is D1, the direction vector of the first line. Then assuming this vector B, 4, 5, 6, is the direction D2 of the second vector. So sorry, second line. Then you can just use the formula,
Yeah.
Then solve for theta. And take note that there could be acute angle or obtuse angle, depending on the value of the of this fraction here. A dot B divided by mod A mod B. Okay? So we already went through. So what you realize is that this is very important. I put a few stars here. You will see this again and again. Dot product will give you angles. Okay, maybe I should write down dot product, the two main points. The two main conclusions you get from it is shadow, aka more formally length of projection. You need to go look at that formula. Length means it's not a vector anymore. Length is a scalar. And the other one would be, what was that we just found? Angle between vectors. Okay, very important, these two. Can? Okay, of course, angle between vectors, which is almost the same as angle between lines, which is also, again, almost the same as angle between planes. Later you'll see. Later, next lesson, this one, planes are too much already, not enough time. I focus on lines first. My homework also give you lines. And dot product, cross product. Okay, can. Oh, not done yet. Oh my goodness. Okay, where am I? Yes, number 3 done already. Angle between lines. Now number 4, problems involving point and a line. Problems involving point and a line. So there are what do you call it? 3 different things you need to learn. Okay. Number 1, number 2, number 3. Number 1 is you want to find the foot of a perpendicular from point P to L. This one is very important. This is like one of the most important problem solving things you need to know. Okay, number 1. Let's take a look. So let's say that you have a line here, L, is vector R equals to A plus lambda B. Okay? And then you have a point A that lies on the line. Let's say you have a point P that's floating on top of the line, and then you drop a perpendicular down until it reaches this base here we call the foot. I should label. This is called the FOOT, foot of the perpendicular from point P to the line L. Okay, foot of the perpendicular from the point P to the line L. And what our goal here is to find out the coordinates of this n. So it's question mark, comma, question mark, comma, question mark. How do we do that? We do that indirectly by finding out what is vector ON, the position vector. Question mark, comma, question mark, comma, question mark. Right, you know, right? It's interchangeable, the coordinates and the position vector.
Yeah.
Just read off the coordinates. So they are the same. They are actually the same. So our goal now is to find out vector ON. How? Here's a trick. Do you remember a special property involving perpendicular vectors? Dot product.
A dot B equals to 0.
Well done, very good. So now A dot B is equal to 0. That's for perpendicular vectors. So can you notice if you just ignore the point NQ for now, focus on the top half only. Do you notice that PN here and the direction vector of the line, they are perpendicular?
Yeah.
I highlighted in blue. I didn't. Sorry. I highlight in green. Okay. So they are perpendicular. So that's our goal. We're going to immediately realize PN is perpendicular to vector D. So we can write down this. Oh, sorry. More like a B. I changed the letter. Sorry. I'm going to put down B. Yeah. So that's what we get here. PN is perpendicular to B. So that means their dot product must be equal to
0.
0 because they are perpendicular. Oh, then what else? Pn. Do you remember at the beginning I told you n minus start, n minus start?
Yeah.
So same thing, we're gonna apply that here. N on minus OA start, OP. Okay? So vector Pn is on minus OP, end minus start. Maybe I should write down n minus OA start. Clear, huh? With bracket. So now what we need to realize is that, wait a minute, on. Oh, that's exactly what I wanted to find, right? Remember the goal? I should write down GOAL. We have our goal ON, but we don't have OP. What do we do? Oh, wait, it's actually given. ABC, let's say, for example. So we can just directly sub in, sorry, let me try again. Okay, we reach ON minus OP bracket dot with vector B already. We don't know what is ON, our goal, but what we know is that point N, it actually lies on the line, correct?
Yeah.
So that means I can actually replace this vector R with ON for some lambda, right? A specific value of lambda you substitute in, then it will convert this vector R into vector ON. Okay?
Yeah.
So that means I can substitute the ON over here with A plus lambda B, the equation of the line, but with a specific value of N, specific value of lambda over here. Then OP leave as OP. So now you have some bunch of numbers, dot product with B equal to 0. You can solve for lambda. After you solve for lambda, what do? Substitute this value of lambda into vector ON. Okay? Vector ON is nothing but this formula here, A plus lambda B. Vector ON will be A plus lambda B for some lambda. Okay? Then that means that you sub in the lambda, you're able to find your vector ON already. Is that clear?
Yeah.
Okay, that is the first point. I know there's no examples, a bit difficult, but I'll just move on for now. Later, then I talk about examples. So next one, point 2, perpendicular distance from point P to L. So what this means is that you want to find out this green color length here, Pn. Okay, also known as AKA means also known as finding out the length of Pn. How do you do that? Very simple. You just, I prefer method 1. Method 1 is my preferred method. Method 2, don't like. You can work it out. I'll explain later. So for method 1, right, what you can do is you can find out vector ON from using step 1, using procedure number 1, correct?
Yeah.
So after you find out vector ON, which is known as the foot of the perpendicular, you can find out vector PN. How? Again, you use n minus start, similar to what we did here. Right? It's exactly the same actually. Correct? Vector Pn is On minus Op.
Correct.
But wait, you might argue, why we want to find vector Pn? Why don't we find vector Np? My answer to that is same lah. You can also do that. It's just that it's multiplied by -1. Right? Pn, Np, they are opposite vectors. P go to N go to P. They are the same. After we find so it'll be OP minus ON or N minus start. It will also work, but at the end of the day, what we are interested in is the length. So it doesn't matter which direction. You just need to find the modular. So square root A square plus B square plus C square. Oh, if you remember the formula, I just write it down here for you in case you forget.
Okay.
Yeah, then you can just find the modulus and you'll get the distance. Is that clear?
Yeah.
Okay, most important thing is you need to draw this diagram. You never draw this diagram or you cannot continue. I noticed in your vector question, you never draw any diagram at all.
Oh,
Very
yeah.
bad. Vector question confirm need to draw diagram. Venn diagram question also need to copy down the diagram. You never draw diagram, very difficult to continue. Okay? Okay, good. Continue. Number 3. Okay, sorry, method 2. Did I talk about cross product?
Yes.
Shortest distance. Cross product here, I didn't go through the explanation, but basically cross product means that you start off with a vector AP. Then you're able to find the perpendicular distance to the theta. So if this here was the theta, the opposite will be Pn, right? So opposite over hypotenuse. So you will be able to find Pn. I did not give the explanation for this. So that's why I don't prefer method 2. I think if you want, you can use the formula, but not that good. I prefer method 1. Why? Why do I prefer method 1? Make a guess.
Like, don't need memorize the formula.
Yes, that is one thing. But the more important thing is that there is synergy. Problems involving point and line. Later on, you also involving point and a plane or line and a plane. It all involves this point number 1. Finding the foot of perpendicular from point to line. It's a similar idea when you have a point to from a point to a plane. Later we change this to plane. Next lesson. It's the same idea. There's synergy in the ideas. You see, in method number 1 of my point number 2, what's the first step? Find vector On. How do you find vector On? Right here. Synergy. What you learn from part 1 carry over to method 1 in part 2. Point number 2, finding the perpendicular distance. But if you suddenly memorize one special method, ad hoc method that only works for this special case, it's a bit stupid, a bit silly, because it means you need to memorize something extra that doesn't link together. If you remember foot, then you can use it to find use it in method 1. It will be faster. In fact, I think usually they will start off with part 1, find the foot. Then part 2, they want you to find the perpendicular distance. So you can just recycle your answer, like a hence question. Then you can save time. So not only is it memorize less, it's also faster in terms of problem solving. Faster. You have to use On. You already found it in part 1, then you can just recycle. Okay. Then moving on to part 3, the last point. Oh, sorry, still got point 5. Sorry. This is still problems involving point and a line. Number 1 is finding foot. Number 2 is finding perpendicular distance from the point P to the line L, the green color line. Now is number 3. We want to find out the coordinates of the reflection of point P in a line L. In other words, you just imagine this as your leg, a line on the leg. Then you have a point P. It's reflected onto a point Q, or you think of it like a mirror. Okay, this is a line of reflection, the mirror. You have a point P on top, you reflect below to point Q. Can understand? You know what's a mirror, so what do you know about Pn is to NQ? What's the ratio?
1:1.
So when I tell you ratio, what do you immediately think of?
The ratio theorem.
Very good. Can you see the hidden duck feet?
Yeah.
The gray triangle, can see or not?
Can.
This time I use purple. But don't use point A. Use a point O, more efficient. Then you get your gray triangle, and then your duck bone. Don't forget your duck bone. Here's the application already. Yeah, just now I promised you an application, right? Here's the application of ratio theorem. So here, because if it's a reflection, we know that the ratio of Pn to NQ is what?
1:1.
Exactly. N is also known as a midpoint because of reflection. N is midpoint because reflection. Symmetry. Okay. So what we know about ratio theorem, we got 1:1 ratio. We know that we can find out the dark bone. Ratio theorem helps you to find dark bone, ON. So vector ON is actually just 1 times OQ plus 1 times OP divided by 2. How do I get this? Let me show you. Maybe I just redraw this. What I start off with is, here is ratio 1, here is vector OQ. So I get 1 times, sorry, I better don't put a cross, I later mix up with cross product. So 1 times OQ. But then you have to add on what? You have to add on, let's say now I choose a different color. Let me pick out the color. Let's say green color. This one ratio 1, and then this vector here opposite. Can see?
1 times OP. 1 dot
1
OP.
times OP. Then all divide by what? All divide by
2.
2. How do you get 2? It's really just the ratio, the sum of the ratio. Here 1, here 1, so 1 plus 1. Okay?
Yeah.
Simplifies to 2, which is exactly what I got here. From here, what you should realize is that vector ON, we already found it from step 1. Notice that? Find the foot of a perpendicular. We already know what's ON.
Yeah.
Oh, this question usually is part 1, then part 2, then part 3. Part 1 given, find foot, meaning we solve for ON. We already found it. So this is a purple tick. How about OQ? What's OQ? Oh, actually, sorry, mix up. Oops. OQ is what we are trying to find, right? So I color it in green. Sorry, I color coded wrongly. OQ is what we are trying to find, right? The reflection of point P. I.e. find OQ. That's our goal, our objective. We want to find OQ. So green color, we don't know. But do we know what's OP?
Yes.
Yes, we do. It's given. Yes, we do. It's given. Maybe I should write those down. Big. P is given. Please go and find out. It will be given in the question. It will be given by the question.
Oh, okay.
The coordinates. P is given. So that means that we also know P. So I put a tick here. Tick OP. We know ON. We know OP. There's only one unknown variable, OQ. Can we solve for OQ? Sorry.
Okay.
Yeah, good. So we can solve for OQ. Let me just change it. Let me read this. Yeah, sorry, there was a typo. Solve for OQ, ON, and OP will be given. Purple color is given. Green color, you need to solve. Okay? This guy. Okay, then you can solve. That is number 3. Very important. This one, every single year will come on. Point number 4, problems involving point and a line. Point 1, point 2, point 3. Next one, last one. Finally, find the length of projection of a vector A onto a line. Oh, sorry, I should get rid of this diagram. I'll just get rid of it. It's a bit messy. Or maybe I just shrink it down and put it somewhere else. Not very relevant. It's blocking my number 5. Just squeeze it here, I guess. You can zoom in. Zoom in, then you can see.
Okay.
Anyways, point number 5, length of projection of a vector A onto a line L. Here is the picture you should have in your mind. Here is line L. Here is the direction vector B parallel to the line L. There's a point A. Then you have, sorry, maybe I should not label that point A. Let's say you got a vector A like this. What is the length of projection of a vector A onto a line L? What does that mean? It means that shadow. Projection, like shadow is projection, right? Projector projects like a shadow. So what you should picture inside your head is this vector. Let me just make it a bit smaller because I'm running out of space. Imagine that there is a sun on top. 太阳, a sun. Okay. Directly on top. It's directly perpendicular to the line. The line is the floor. What happens? Can you see?
Like it's
pink color shadow?
Yeah.
Pink color shadow. That's what the question is asking you to find. This is a very chim way of saying length of projection of a vector A onto a line L. It's asking you to find Michael Jackson's shadow. Michael Jackson, he stands slanted. Then there's a shadow because the sun is on top. They want you to find the length of the shadow. That's what they're asking. But of course, you can't just tell them it's a shadow. You have to do the dot product formula. A dot with the vector B, but you have the unit vector. And the unit vector here is basically any vector that is parallel to the line. It doesn't have to be on the line itself. The vector B could just be the vector that is parallel to the line L, but it doesn't have to be on the line L. It just has to be parallel to line L, direction vector. And the length of that vector doesn't matter because at the end of the day, what's the formula here? Is it just B or B cap?
B cap.
B cap means what? It's a what kind of vector?
Unit vector.
Unit vector means its length what?
1.
Exactly. So that's why the length doesn't matter. It will always be length 1. Okay. Unit vector, always length 1. Vector implies length 1. Imply that vector B's length doesn't matter. All right. Just require B to be parallel to line L.
So
and you can
on the vector itself, right?
It does not need to. It can.
Okay.
If it happens to be, then even better. We just need them to be parallel. Parallel. Can see parallel? Yeah, it doesn't matter. Just parallel. That's the main point. Okay. Parallel. Do I have time to go through an example? Ken?
Ken, do you have time?
I have time.
Okay.
Oh, do you want a short break first? Because actually I need to use the toilet a bit.
Yeah, sure.
Okay, can we okay, I find the question for you. Let me see. Sorry. Can you look at question 17? Okay, go think about it.
Okay.
We'll return in 5 minutes. I'll come back at 11:26.
Okay.
That or earlier. You take a look at it and maybe you can try the question first. Then I'll go through. Okay, 5 minutes. Okay. Right. I'll pause share. Oh wait, maybe I'll just share the PDF with you now. Then you can take a look at the PDF and try the question for 5 minutes. Okay?
Okay.
Share this. Okay, sent. All right, have a pause, have a break. Okay, Ken, do you want me to check your work or should I just go through?
I don't think what I wrote is correct.
Okay, then you mark your own work. I think I'll just go through. Okay, question 17. Let's go. Ken? So find the foot of the perpendicular from the point P12 -6 to the line L r equals 2i minus 3j plus lambda times bracket 2i minus 2j plus k, where lambda is an element of the set of all real numbers. Hence, find the distance from point P to L and find the mirror image of P. I'll just denote this by P prime in L. We find the coordinates of P prime. Okay, how do we do that? First thing first, copy down the line. Okay, I'll use black. Slowly. R equals to 2i minus 3j. You notice something weird? Where's my k? ijk, where's my k?
Is 0.
Okay, so 2 minus 3, 0. That's your point. Plus lambda multiplied by 2i minus 2j plus k. So 2 minus 2 and 1. Lambda element real numbers. Okay?
Okay.
That's your line L. Then you have a point P, 1, 2, -6. What's the mistake I made here? If I try to continue, no diagram. Very bad.
Oh.
Draw a diagram. Please draw a diagram. So that's L. I'll just copy down the equation. Maybe, okay, no space, then I'll just put L. I don't bother. Usually, if you got space, I will put in the equation. But I think, never mind, forget it. No space. Then you draw a point P on top, 1, 2, -6, just like the notes. Instead of ABC, now it's 1, 2, -6. What do they want? Find the foot of the perpendicular. What does it mean? You must draw your own diagram. Here is a perpendicular line. We want to find out the foot. Usually we let n be the foot. I don't know why it's n. It's just the way it is. Sometimes you put the letter F also, okay. Let n be the foot of perpendicular. From P to L. Can?
Can.
Coordinates are to be found, but in the form of ON, vector ON. That's what we are trying to find, vector ON. Can you tell me two vectors that are perpendicular?
The 1, 2, -6 and 2, -3, 0.
Wrong. Let me show you.
The 2, -2, 1. It's the direction vector.
Correct. So what is missing on my diagram? It's incomplete. Your line L always got two parts, right? Can you tell me what's 2 - 3, 0? What does it represent?
The position vector.
Position vector. So it's basically telling you there is a point that's whose coordinates. Let's just call this point A, for example. Yeah, it's always conventionally point A. It passes through the point 2, -3, 0. Then there's a origin maybe somewhere here, and then there's a vector here, 2, -3, 0. Okay, this is getting a bit irritating. I'm gonna spill over to the next line like this. I need more space. Okay, much better. Okay, better. Yes, I got more space to draw. Yay. Okay, what was I saying? Vector OA here is this point here, 2, -3, 0. Don't be confused. This vector, look, is it perpendicular to the line L? Is it perpendicular to PN? No, absolutely not. So you don't look at OA. No, don't look at 2, -3, 0. Focus on this fellow. What is this vector again? Direction vector. Yes, you already told me. How do you draw direction vector? Is it like this, parallel to PN?
No, it's perpendicular.
Perpendicular to PN. In other words, it's parallel to the line L, like this. This is 2, -2, 1 vector. And yes, you're correct. It is perpendicular. These two fellows are perpendicular. So can you tell me, is it OP? OP is like this, that is perpendicular to the direction vector 2, -2, 1?
No, it's PN.
No, right? It's PN. If you look at the notes, I sent you already. It's not OP, it's PN. So at the beginning, you told me OP. Wrong. If you write down for me OP, which is 1, 2, -6, then you dot product with 2 - 2, 1 equals to 0. That's totally wrong. You just double check. Is it 0?
No.
1 times 2. 2 - 2, -4, -6. Definitely not. It's not 0. So this is nonsense. No. Instead, you should be focusing on direction vector of the line, direction vector, and PN. In other words, as what I wrote in the lecture notes, vector PN perpendicular to vector direction vector. I use a letter B. That's my convention. But in the practical question, it's actually just the vector 2, -2, 1. Where did I get my vector B from? Over here.
Yeah, direction.
From the equation of the straight line. Can? Not confused, I hope. Equals to what? Perpendicular implies that the what is equal to what?
The dot product is 0.
Very good. Pn dot with the vector 2, -2, 1 is equal to kosong. Okay, this is getting a bit irritating and taking up my space. I'm gonna toss it aside. I need more space. Okay. Like this. Okay. Then what? What did I do with my PN?
It is sub in. It's like ON minus OP.
Very good. Sub in with ON minus OP. But then dot with 2, -2, 1. What's missing? What's missing?
Huh?
Compare lecture notes. What I wrote down. You never write this down, it will be wrong. Confirm will make careless mistake. Can you see? What's missing? Compare and contrast with the lecture notes.
Bracket.
Yes, bracket are very important.
Oh.
Must have the bracket. Okay. Oh, you couldn't detect this. Means that you make this. Okay. I prevented a mistake from happening. Okay. Good. Do we know what's ON?
No.
But is there a way that is there something special about ON? Point N? Where is it? Is the
It lies on the line.
good? It lies on the line. So what does it mean? What can we do with ON?
Can sub in the equation on the line.
Exactly. Because it lies on ON. So this vector R can replace with vector ON. Oh, you just need to pick a specific number of lambda. You pick the correct lambda value. Then you simplify this. It will become ON. Because N lies on the straight line L. Okay, that's how a vector equation of a line works. You choose a correct lambda, then you can get R. But of course, we cannot just tikam and pick a lambda. Algebra, right? You have to solve for lambda. Right. So that's what we're gonna do first. We're gonna know that we are allowed to substitute the ON. So we are gonna just replace it with 2 minus 3 0 plus lambda times of 2 negative 2 1, which is equation of the straight line. Maybe I'll just color code it in purple. Don't forget a minus OP. Dot product with 2 minus 2 1. Right hand side equals to what? Still 0. Nothing happened. What did I miss out on? I made a mistake. What's missing?
The bracket again.
Yes. You missed the bracket again. Must have bracket. You cannot suddenly have bracket and drop the bracket again. I just do substitution doesn't mean the bracket will disappear. Understand?
Okay.
Must have bracket. Okay. Okay. Good. But wait a minute. Do I know what's OP?
Yes. The question gives.
The question is given by the question. Given. So what should you do? If you're faster, you can just substitute in straight away. So I'm just going to write down my OP, which happens to be 1, 2, negative 6, right? So I put down 1, 2, negative 6. Is this correct?
Yes.
Wrong. What's missing?
The bracket.
I purposely erase it. I'm testing you. Wow. Okay, cannot catch. Okay. So yeah, missing bracket. Always have a bracket. I think by now you get it already. Get the drill. Must have bracket. Okay, so why bracket? Because you must do order of operation. Must do the bracket first before you do dot product. Or in other words, you need to distribute across the bracket. But I think it's simpler if we combine into one single vector first, then later we deal with the dot product. So let's do that. Let's simplify this. 2 plus 2 lambda. Can you tell me the rest?
Minus 1.
Minus 1. Oh, even faster. Can. Then next line.
Negative 3 minus 2 lambda minus 2.
Good.
And lambda plus 6. Bracket.
Lambda plus 6. This one not bracket anymore. It's a vector. Can you see that it's vector plus lambda times of vector minus a vector? You get a vector. So I'm dealing with the purple and the black. Becomes one single vector. Then, yes, bracket. And then you dot product with 2 minus 2 negative 1. Positive 1. Can? But of course here, you can drop the bracket. Why? Because now you only got a single term. You see, previously you had 1, 2, 3 terms. That's why you need bracket. 2 or more terms, you need bracket before multiplying. Here, there's only a single term, so you can drop the bracket. Okay, so I'm just going to remove the bracket like this. Okay? Dot product, how? Maybe I simplify a bit more. 2 minus 1 is a 1, so 2 lambda plus 1. Minus 3 minus 2 lambda minus 2. Minus 3 minus 2 is minus 5. Don't forget negative 2 lambda. Lambda plus 6 is lambda plus 6. Right? I'm just simplifying, right? 2 minus 1 is plus 1. Minus 3 minus 2 is minus 5. And then you dot product with 2 minus 2, 1 equals 0. Continue.
So it's 4 lambda plus 2. Then
Continue. Yes, good, good.
minus 4.
Wrong.
4 lambda.
Okay, you know what?
No.
Stop. Too fast already. For you, you are very careless with your minus sign. I want you to write down standard format. Something times something plus something times something plus something times something. Write this down first.
Okay.
Equals to 0. Okay, so what is that? I think you know. 2 lambda plus 1 times 2. Negative 2 lambda. I'm doing this because I'm scared that you make careless mistake. I'm trying to help you. Okay?
Yeah.
Can? But if
Yeah.
you're faster, then go ahead. But you made a mistake already, that's why I'm scared. Anyways, continue. Yes, you were saying 4 lambda plus 2 and
4 lambda plus 10.
very good. Positive 4 lambda plus 10 because double negative become positive. And
Lambda plus 6.
well done. Equals to 0. Right? This one, okay, right? Equals 0.
Yeah.
Okay, then combine like terms. Use calculator lah. 4, 4, 1.
9 lambda plus 18 equals
Good.
to 0. So lambda is 2.
Very good. Wrong. Wrong. Oh no.
Negative 2, negative 2.
If you need, do it step by step. Bring the 18 over negative 18. Then divide by 9. Negative 2. Good. Negative 2, done. Then what's the goal of the question? Find foot. Find coordinates of n. Sorry, can you tell me again what's the goal?
Find the foot. Find the
Which is
coordinates of n, so can start back into the line.
correct. Yes, sub back into the line here, right?
Yeah.
This guy. So to find this ON vector, all you need to do is to take your lambda, substitute back into this equation, then your R will be your ON. So that's what I'm going to do. I will copy down the equation because my iPad cannot show everything on one screen. So I'll paste it here just to remind myself. You don't need to do this. You don't need to copy down. You just have to look up on your piece of paper. For me, my iPad a bit small, so I need to copy down. Yeah, so therefore you conclude that ON is actually just copy down the equation and then you substitute lambda with
negative 2.
Okay, can you try and simplify this step by step? So 2, negative 3, 0, then times the negative 2 in. What do you get? Plus?
Plus negative 4, 4 and negative 2.
Good. Then you combine into a single one. 2 minus 4.
So negative 2.
Continue.
And negative 2.
Well done. Good. So in other words, the coordinates of n is negative 2, 1, negative 2, right?
Yeah.
Okay, then we have found part 1. Let's move on. Maybe find foot, I'll call it part 1. Part 2, part 2, hence find distance from P to L. Let's call it part 2. How?
Is it like modulus?
Modulus of what? What's this distance from P to L actually referring to?
Modulus of Pn.
Pn, very good. So that's actually what we're trying to find. Modulus of Pn. If you just look at my lecture notes, yeah, that's exactly what you need. So, what's Pn? Always remember, what minus what?
It's On minus Op.
N minus start, N minus start, N minus start. Must remember On minus OP. Good. Do you know On? Yeah, we just found. That's from part 1. Right? You remember On? Yeah.
Yeah.
What else? Do we have OP?
Yeah.
Look back at the diagram. Given 1, 2, negative 6, then just sub in, no? OP. Yeah. Then after you subtract, then you find modulus. So let's just do it. So first step would be to find out Pn. How do I? Okay, you know what? Give me a second. Let me just screenshot this. And then I'll paste it at the bottom as an image like this so you can have a reference. Yeah, so what was I saying? Find vector Pn first. So it's really just n minus start We already know what is ON also. I'm just going to squeeze it all on the same line. Technically, for presentation, you should put down below here, then you continue. But due to space constraint, I'm going to put it all in the same line. So it's a -2, 1, -2, correct?
Yeah.
Yes. And then you have to subtract away OP. What's OP?
The 1, 2, -6.
Very good. Subtract, what do you get?
-3, -1, 4.
-3, -1, and +6, 4. Yeah, correct. Well done. Okay, let me just write it neatly. -3, -1, 4. Okay, that is my PN. What do I need? Perpendicular distance, which we already know ahead of time just now. It's this guy, right? Modulus of PN. So we can just find the modulus of this -3, -1, 4. So take note, -3 bracket around it, then square. Are we clear? It's different from -3, then bracket square. Or if you never put a bracket. This is wrong. This is correct. This is the same as minus bracket 3, then square. So the square applies to the 3 itself. So this becomes minus 3 squared, 9. Totally different. We must have bracket. Then -3 times -3, negative times negative gives you positive, and so on and so forth. Just make sure you don't do this. This is absolutely wrong. No. Your bracket is important. Must be around the -3. Continue, plus bracket -1 close bracket square plus last one bracket 4 square. Clear? So here, if you type in the calculator directly, what do you get?
Square root of 26.
Very good. You didn't fall for my trick. If you just give me the 5.099, I will have to remind you, don't do it. Give the exact form. Give the exact form. It's better. So don't evaluate the square root. Just calculate what's in between, which is 24, right? Let me just confirm.
26.
26. 26. Yeah. Yes, 26. Yes, much better. Let me think. 9, 1, 16. 10 plus 16, 26. Yep. Okay, so square root 26, which is your decimals 5.099. I don't want the decimal, I want exact answer. Can? Okay, good. Carry on. That is part 2 done. Part 3, let's move on to part 3. Part 3 request for mirror image. So let me just copy down my diagram. Due to space constraint, I need the diagram. This is now question 17, part 3. What's my coordinates of n again? 9, -2, 1, -2. So I'm just gonna fill in the blank in my diagram. Make it easier to read. I don't have to keep going back and forth. I just look at my diagram, I can understand everything. You know what? I'm just gonna copy down the equation of the line as well. 2 - 3, 0. Just squeeze it in. 2 - 3, 0 plus lambda times of what was that? 2, -2, 1. Okay. I can remove this. So this diagram is all I need. What was the question? It's asking me to find the coordinates of a P prime, a reflection of P about the line L. So where's my P prime? Can you draw on the diagram using a mouse annotate function?
It's an annotate function.
Yes, there is. Do I need to give you make co-host?
It's like oh.
Where is it? Where is P prime?
How to annotate?
Press.
Right.
Are you on the laptop? It's 3 dots. Then you can draw. I'm using the app. So I can just I'm using the Zoom app. So are you using the website like Chrome?
Yeah. I'm using the website.
I'm not so sure about the format on there, but I think one of the buttons, if you see the black bar, there's 3 dots. Then there's a draw function, annotate function.
Don't have.
Okay, can. How do I get you to share? Okay, so where would it be? Can you describe to me verbally? Where do you think the P prime should be at?
It's like directly below N, like the same magnitude as P.
Here,
Yeah.
Okay, yes, correct. Okay, don't need to test on. Okay, good. Yes, you know where is P prime here, huh?
Yeah.
Good. So same magnitude. Then you can just extend the line a bit, which is exactly the same as the lecture note. 换汤不换药. You change the form, but you don't really change the ingredients inside. Basically, it's the same type of question every single time. Let me just clear the diagram. Okay, I need to figure out how to get you to draw. Later. So here is P prime. We want to find out coordinates of P prime. What are we supposed to do?
I use the ratio theorem.
So how? Can you, let's say I draw a separate triangle. Do I use point A or do I use point O?
Use point O.
This triangle or that triangle?
The one is point O.
Point O, very good. Yes, much better. Why? Because it will be easier to get our vectors. Like vector OP, Our vector OP here, straight away you can just read off coordinates. If you use a point A, how? You need to get vector AP. Then you need to do N minus start. OP minus OA. Very troublesome. You'll get the same answer, but no point. Ratio theorem, just go straight for O. Always use a point O. Okay, so here is my point P. Here's my point P prime. What's missing? Oh, maybe I should make it directly on top. Something along these lines, like this and like this. Okay. What's missing?
The line in the middle, the ON.
Very good. The duck feet. Okay, duck bone. Remember duck bone. Here is point N. Then
the ratio.
What's the ratio?
1:1.
Sorry, my diagram is not nice. Do you want me to make it nicer?
It's okay.
I think it's better. I don't want to confuse you. I better make it symmetrical. Yeah. So, oops, sorry. I mean to make it like the same length because 1:1, right? But of course, during exam they will not mark your diagram, so it's fine if you don't draw it accurately. Yeah, the ratio is 1:1. Good. So yeah, how do you continue? Ratio theorem.
1 of OP plus 1 of OP prime over 2 equals to ON.
Equals to what again on the left hand side?
ON.
Vector ON. Very good. Okay, what do we know?
The ON and the OP.
ON is what?
ON is the -2, 1, -2.
Good. Equals?
The 1, 2, -6.
1, 2, -6. Good.
Plus the vector OP prime over 2.
Okay, good. Then you can solve for OP prime, right?
Yeah.
It's a bit like for example 3 equals to 4 plus x over 5. How to solve for x?
Like must times 5, then bring the 4 over, so become -4.
Exactly. You get the idea. So here the 3, 4, 5 is like your vector, and number 2. Here your x is like your OP prime. So it's the same thing. Can you understand?
Can.
Okay, so that's what we're going to do. Times 2 over, but it's scalar multiplication, so you need to times into everything, but I'll just do it step by step. Equals to the numerator. Maybe it's confusing. Some students have trouble with solving for x like this when the x is on the right side. So what I do is I swap them around like this. Right go to left, left go to right. It helps a lot. And then you solve for OP prime. Plus a number. What do you do when you bring over? Becomes a
minus.
Minus. Okay, so that means you can get your OP prime on its own equals to right hand side, copy and paste like this, 2 times of whatever. And then you need to bring this 1, 2, -6 over to the right hand side. But with a plus or minus?
Minus.
-4, so also minus here. Okay, then we can solve for OP prime. Let us do that. 2 multiply in minus 2 times 2 is 4, 2 times 1 is 2, 2 times -2 is -4. And then you subtract away 1, 2, -6. Simplify, save space. Sorry, I should write it over here, but save space and I write over here. -4 minus 1 is -5. 2 minus 2 is 0. -4 minus -6 plus 6, so +2. Clear?
Yeah.
That's OP prime. And therefore, we are done. P prime is -502. Yes?
Yeah.
Easy?
Kind of.
Please remember this procedure. Remember, every time you see start to see like foot of perpendicular, it's really just asking you to go through this procedure. Part 1, part 2, part 3. This question is very standard. You need to practice and practice and practice until you can do it like, wow, 2 minutes, 3 minutes, you can finish. Okay? Here I went through very slowly. 20 minutes, wow, very slow. No, you must go faster.
Okay.
Your answer key, you see, sometimes what they'll do, they won't even write down the equation of the line. They'll just jump straight to this line, you know. They'll start here. So you don't get confused. I hope you know how to read answer key. They'll start from here. They won't go and slowly explain to you, oh, perpendicular dot product equals 0. Then you split it out into ON minus OP. Then you substitute ON, substitute OP, blah, blah, blah. They won't. They just start right from here with bracket. I hope you understand.
Yeah.
And watch the video again if you don't understand. Yeah. What else? The solution. Yeah. I want to go through the solution a little bit. Just some of the questions. Like paper 2 one. Was it paper 2 about the vectors question? The missile one. Was it paper 2? I can't remember. Yeah, I sent you the solution already, right? Okay. Paper 2. ASR, JC. Yeah. If I can find it first. Wow. Okay. Yeah, it's basically the same thing. Oh yeah, I haven't talked about planes. So okay, let's just take a look at this one. Question 3, part 4 from the ASRJC. Yeah, so for the ASRJC paper question paper 2, question 3, part 4. Let me find the question first. Yes, they are talking about a drone carrying a bomb, departs from a point A, it flies in the direction of whatever, and across a lake to a target location. Then they gave you the equation of the lake, which is a plane. Then part 1 asks you to find the value of A if the drone makes an angle of pi/3 radians with the surface of the lake. But then blah, 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 part 2, later on they give you the value of A, you have to use the A equal to 2. Then a missile is launched to intercept the drone. So what this means is the drone is flying in this direction, then the missile is flying in another direction. They intercept over here, which is a point of intersection. So they are trying to hint to you that you need to find the intersection between the 2 lines. I think I demonstrated just now already during class. Yeah. That's the part 2. Then part 3 there, at the point of intersection, this point P, a piece of drone, it hits, then a piece of it drops to the bottom of the lake. But it will fall perpendicular because of gravity. And it will meet the surface at this point N. This is an indirect way of telling you, here's the foot of the perpendicular. And I just went through with you how to find the foot, right? That's what part 3 is asking you to do. Or you can go and try the question again. I think this time it will be clearer. And read the solution if you need to. Then part 4 is denoting the line L. Let's read the question. Part 4 is saying denoting the line that contains the drone's path as L1. This guy is L1. And L1 prime being the reflection of L1 here. Right? Clear so far?
Yeah.
What did they say about this? They said that you want to find a vector equation of L1 prime. Okay, I haven't went through with you how exactly to do it. But the basic idea here is, can you see magic gray triangle?
Yeah.
Can you see duck feet? Oh, I forgot to draw a duck feet. Duck bone. Can see?
Yeah.
So then you can just, what's the ratio of Pn to Np prime?
1 to 1.
1:1. Then you can use ratio theorem and solve. So but the difficulty is, should you use point B or should you use a point O?
Point O.
Should use a point O, right? So over here in my work solution, I use point B. Very silly of me, I go and use point B. Then yeah, so I told you that, I think I gave a comment. Redraw, point A is on the plane. Oh yeah, okay, I made some extra step. I go and find out that point A is actually on the plane. Yeah, I made a point here. I made use of point A. Actually, I didn't have to. You can simply use the origin point O. It will be a lot simpler. Okay, and you can read the answer key, the type solution. That's what they use. Use the origin. Yeah, I'm not gonna elaborate further. You can go and read on your own. basically it's the same goal again. It's a dark bone here, and there's a gray triangle ratio 1:1. 1 times OP prime, 1 times OP divided by 2 equals to vector ON. Then solve for OP prime. It's the same procedure. Okay?
Okay.
Yeah. All right. And anything else I should take note of? Okay, homework questions. So do you think you can handle 40 questions?
Oh, yeah, by when?
Wait, yeah. The next lesson is on. Okay, I think I should just stop the recording.